Hi, welcome to Effective Gradle Implementation Screencast from Pack Publishing. My name is Ryan Vanderwerf. I'm the Chief Systems and Software Architect and Director of Products at ReachForce. I'm also co-founder of Zan Endeavors LLC, a collaboration of software development, consulting, coaching, and innovation games. I'm formerly lead architect at developerprogram.com, and in the past I've built Java and Linux-based webcasting for events such as South by Southwest, telecom software, and SaaS systems for the financial sector.
Hi, my name is Lee Fox. I'm a senior technical architect at 3M, also co-founder of Zan Endeavors LLC with Ryan. Formerly, I was a senior technical architect at AT&T Wi-Fi Services, applications architect for Borland, and lead cloud architect for Pervasive Software. We'll be walking you through the process on how to effectively use the Gradle build tool to make managing, building, and deploying your applications easier. Gradle is a powerful and flexible build tool that brings the power of Groovy, Ant, and Maven together. It provides a powerful Groovy-based DSL scripting language, plugins, and multi-language support. All of that power is the reason why Gradle is a great choice for a shop's build tool. However, if you're a skeptic like I am, you will want to know more. Gradleware.com tells us that Gradle is a proven technology that can handle builds at scale. The site tells us that there are large organizations with some rather impressive build needs using Gradle. LinkedIn, Netflix, and Orbitz are just a few of these companies. Gradle is gaining popularity in the large Java and Groovy communities. A couple of large projects like Hibernate and Grails are utilizing Gradle. The large community enjoyed by Gradle is also further enhanced by Gradleware Incorporated, which brings professional support to the table. If you opt to use Gradle, you won't require support from a community of professionals, but you can rest assured it's there if you need it. We will break the screencast up across a total of 2 hours, split into sections across topics, different languages, and continuous integration. Examples will be shown and covered, which is important because you will not only learn how to set your build up properly, but see live examples on how to do it. I think for topics like Gradle, a hands-on approach will cost you less of your free time than reading a book, and also give you more practical hands-on knowledge. If you want to dive further into the special topics, a book will definitely provide that for you, though. Prerequisites. You must have Java JDK 1.5 or higher installed to run and install Gradle. Gradle ships with its own Groovy library, so keep in mind that if you have Groovy installed already, Gradle's going to ignore that installation and use its own. Installation binaries are available for download from www.gradle.org/downloads.
Hi, I'm Ryan Vanderwerf, and I'm here to talk today about how to best install and maintain your Gradle versions. I'm talking about a tool called GVM, or Groovy Environment Manager, written by Marco Vermeulen, which can be found at gvmtool.net. First, you will need to already have a JDK installed in your system. Once you have that configured and running, you're ready to install GVM and Gradle. This tool is a great way to automatically download and manage your Gradle versions, but it also works for Groovy Grails, Vertex, Lazybones, Griffin, and more. GVM is run in Bash, so it will work great on Mac, OS X, Linux, and most Unixes, as well as Windows with Cygwin installed. To get started, I'll go ahead and follow the instructions on their website. All we need to do is go to their website, copy this one-line command to your terminal window, like so, and we'll install GVM. I already have it installed, so it won't download again, but if you were new, it would download it and install it and give you this same message. Now let's go ahead and show that what Gradle versions we've installed. So if we type GVM list Gradle, it will show us all the versions available for installation. At this point, my current version, which is marked by the greater than sign, is version 1.12. If I'd like to switch back between versions, I just type GVM use Gradle and the version number. So if I want to use 1.11, I just run this command. Everything is switched over, all my paths and environment variables, Gradle home, all of that's taken care of for you. So this is a great tool to hop between different versions if you've got many software projects running different versions of it and you're not already using the wrapper. Now let's set up a quick Gradle build to show that everything is working properly. If I run Gradle init, it'll create a sample project for me. And inside the sample project, it creates a few files. It creates a Gradle wrapper file, which you can run and it'll auto-download Gradle if you don't already have it. It'll give you a build.gradle file, which is the main file that controls everything about your build, and then a settings.gradle file. Let's go ahead and look inside the build.gradle file really quickly, and we'll cover more of this in later. It will, by default, be entirely commented out. If you uncomment it, it will apply the Java plugin. Let's go ahead and do that. And create some dependencies, like log4j and JUnit. So now if I want to make sure this is working, I just type Gradle tasks, and it will show me the available Gradle task commands I can run. There we go. So now we have a Java plugin installed. I have lots of options for the Java plugin. If you run other plugins of Gradle, it'll add other tasks that you can also run from there. And this concludes the section for using GVM. We'll cover later the Gradle wrapper and in detail of all the different kinds of projects you can run. If you're not using GVM to install Gradle on Windows, here's how you go ahead and do it manually. Once you get to the Gradle.org website, download the version that you're going to run. I've gone ahead and already downloaded 1.11. So once we have that unzipped, go into your system properties, environment variables, go to your path. Let's go ahead and edit that. Make sure you've added wherever you've unzipped your Gradle to into your path. So it'll be, in this example, c:/Gradle 1-11/bin. And after that, go ahead and add a variable called Gradle_home. And then go ahead and set that to the directory you unzipped here. See what I'm pointing at? So I've gone ahead and done that. And now I should be able to tell Gradle is installed. I can type Gradle-version. Go ahead, it tells me I've got Gradle 1.11 installed. Now I can go say Gradle init, and I can make a test application. All right, so now I can show here that it's working. Now I have a sample Gradle file. And this is a generic Gradle file that I can open and create a basic Java program on. So from here, you're ready to go. This is Windows 7. Windows 8 is the same process. Just right-click on My Computer, Properties, System, Environment Variables, and you're done.
Okay, so we're going to install Gradle on the Mac OS X now. And the steps are going to be almost the same as we've done and we're going to do for Windows and Linux platforms. We're going to start off by going to gradle.org/downloads. And at the bottom, there's going to be a drop-down list for us to choose different versions from, the one you want to download. I've already downloaded Gradle 1.11, as you can see there on the desktop. And I did that to save us some time while we were creating this video. Now, to get this guy installed, I'm going to go to I'm going to open up a terminal window or command line. I'm going to edit the .profile file. And in here, I'm going to set a couple of environment variables. So Gradle home is our most important environment variable. Let's go ahead and get that set. It's going to be set to the directory where we exploded the zip file we downloaded to. We also need to call the binaries and the executables from Gradle. So those will have to appear in our path. And I'm going to be nice enough to respect any path that was there previously. And I'm also going to add in the Gradle home that we just created, specifically the bin directory within it. Now, with that saved, I am going to source the .profile file. This is going to execute the commands in there and set those environment variables for us. At this point, Gradle's installed, but let's make sure that it really is and it works. Gradle-v will report to us the version. There is Gradle 1.11. Remember, we downloaded 1.11 earlier. Now I'm going to make a directory called Gradle test and change into that directory. I actually want to make Gradle work now and exercise it. So Gradle init will create a project, bare bones minimum Gradle project. It'll be as close to nothing as you could possibly be and still be a Gradle project. Now we can see that was successful.
And if I do a listing of the files in there, there's build.gradle, Gradle w.bat, settings.gradle. These are all files that we're going to be talking about in the rest of the screencast. So we'll discuss those later. It's here. Let's make sure that even this works. Gradle tasks will analyze our build.gradle file where we have all of our work. It will look at all the tasks that are in there, and it will analyze any tasks that we've inherited from other projects and display them to us in a cohesive list, which we have right here. So at this point, Gradle is installed on OS X, and it works.
To install Gradle on Linux, the instructions are very similar to the Mac OS X instructions. Go ahead and make sure you've downloaded your Gradle binaries from the Gradle.org website. Make sure you unzip them to a directory, and we'll get started. And all we have to do is go into our home directory, type cd, and then we'll go ahead and edit the bash profile. And all we need to do is make sure we have our Java home set, if you don't already have that set. Once you have that, make sure you set your Gradle home directory, and make sure you set your path to reflect your Gradle home directory. So once we have that set, I've got it already downloaded. Go ahead and write that out to disk, and type Gradle-V. And now we've got our Gradle version 1.11 there. Let's go ahead and do a test. Make sure everything's functioning properly. Run Gradle init to create a blank project. Done. Now we'll run Gradle tasks to verify all of our tasks are there and our Bootstrap project is working. And we're done. Gradle is now configured in Linux. Troubleshooting installations. You may run into some problems trying to install Java or Gradle. And let's go over some of the commonly encountered issues. Let's start with botched Java installations. If your Java is not properly installed, you may see errors such as no command Java found. Double check that your JDK is installed properly for your platform. Let's look at Stack Overflow for some commonly encountered problems. Here we've got an example of someone's path isn't set up after they installed on Windows. You have to remember that you have to set Java home and the path manually in the Windows control panel under System Variable Settings. If you don't, it will not work properly. Other common problems you may encounter are incorrect path settings to Java binaries, installing the JRE instead of the JDK, and this includes the javac command. Java home not set for your environment, or the wrong version of JDK installed for your platform. That's another problem someone ran into here on Stack Overflow, where they've installed the 64-bit JDK on a 32-bit system, and it can't, even though they think they've set everything up properly, it never finds the executable for Java. So that's another thing to make sure to watch out for, because it can definitely lead you in a wild goose chase trying to figure out what's going on. Another problem you may run into is you may see an error such as minor or major version and then a number. That means you might be running a newer version of a compiled class on an older version of a JDK or JRE. That may mean your versions are mixed up. Look at this Stack Overflow post here to make sure you've got all your path settings set correctly and to help you troubleshoot the problem. The most common problem for this is you have more than one version of the JDK or JRE installed and the paths are all crossed with each other, or one home directories for Java is pointed to a binary of another. You may run into another problem such as Gradle command not found, and if you're running into that problem, you need to make sure you check that your Gradle is installed properly. So let's go to a terminal prompt here, and we can type which Gradle, and it'll tell us where it's currently installed. If you run which Gradle on Mac OS X or Linux and you don't get any results, something's wrong with your path statement. That means your Gradle binary home directory is not set up correctly. Another problem you may run into is on Windows, you may run into the same problem. You use the where command. So you could say where gradle.bat. And if you don't find any results, check your binary settings. Make sure you've restarted your command prompt after you've changed your control panel settings. And that should resolve the issue for you. Another common problem is running the wrong platform of Gradle. So you may run into a situation where you're running the Gradle W command when you mean to run Gradle command, or you may be actually running a batch file on Linux or OS X and not the plain Gradle commands. If I look in the Gradle bin directory here, see for my platform, I'm on Linux, I can run the Gradle command and it runs properly. But if I try to run the Gradle.bat, I'll get a bunch of strange errors. And so if you're on Windows, you make sure you run the bat command, not the other command, or you're going to run into the opposite problems that it just showed you here. You may also run into permissions problems. So sometimes if you unzip your Gradle with the wrong username, say you're as root or an administrator and you're not as the current user logged in, you may run into a problem there as well. So for example, on Linux here, if I look at the permissions on these files here, I've got my owner is me, and that's my username. So I don't have any problem reading or write these files. These are all the permissions for the executables of Gradle. And if these aren't set properly, or only the owner, who is a root user, can read or execute them, you may get a command not found anyway because you don't have access to those directories. Depending on your platform, it may say access denied, or it may act like they're just not there. We've got a good example here of a web page I put into your slides. It describes how permissions work in Unix, so these would apply to OS X and to Linux. So take a look at this page here and understand how permissions work, what ch user commands do, what these flags are, and how to run them. And once you understand that, you'll be in much better shape trying to troubleshoot these kind of problems if you're running into that. Problems with the Gradle daemon. Sometimes users have a problem with the Gradle daemon command, and you might need to disable it. Run the command gradle-no-daemon and see if that helps. If that does not fix it, let's check out the docs here in a second. But why is the Gradle daemon important? The Gradle daemon or build daemon is used to boost performance of your build. Instead of loading libraries and resources each time Gradle runs, it can keep these resources loaded to quickly make the build go faster. If you don't have these things going, it'll start and stop the JVM every single time. So not only does it make things load quickly, but it also gives IDEs a way to use Gradle resources for helping with auto-completion and syntax. Finally, if you want to use a tooling API, you must have the Gradle daemon working properly. So if it's not working, let's go check out the Gradle page here to find out why that is. We've got the full documentation here and steps to troubleshoot why that is. And usually it's pretty unusual you'd have a problem with this unless you're running an older operating system or something fairly unusual as far as your distribution. So if it's not working for you and the no daemon command did help, definitely research this to find out why that's not working to make your IDE perform better and your builds perform better.
Okay, so far we've talked about Gradle and we've done some Gradle installations. We've also talked about problems with those installations and troubleshot them. So we are at the point where we should have a good, clean Gradle installation. Let's see what's actually out there. I'm going to move to my Gradle home directory. Now, I don't know where it is off the top of my head, so I'm just going to use the environment variable to get there. Let's see what's out here. Got a couple of directories. We're going to talk about each one of those in just a moment. I want to draw your attention to the license file. This is an Apache 2.0 license for Gradle. This is going to be important for those of you developers out there who are going to be doing some work that you may want to distribute. The bin directory, it is small but very important. It's the heart and soul of what keeps Gradle running. It's got our Gradle executable and it's got our gradle.bat files for Windows. Our docs directory contains several different types of resources. These are all HTML files, so let's switch over to a browser real quick. We'll see that there's a Gradle release notes file that'll tell you all the changes and things that are new and noteworthy for that particular version of Gradle that you have. There's a DSL document that will tell you all of the information you'll need to know about the Gradle DSLs that are available to you. There are some Java docs for programmatic use of Gradle on the Java side. There are Groovy docs, same thing, Groovy side. There is also a user guide here, which is probably going to be one of the most important documents for you to reference. It is going to have all the documentation that you could potentially need for Gradle. It'll cover everything that we cover in this screencast and a lot more. Back to our command prompt. So we've talked about, let's go up a directory to our root. We talked about the docs. What's next? init.d. This directory is pretty much empty save for a readme.txt, which I want to show you the contents of. It's important. You can add .gradle and .scripts to this directory. Each one is executed at the start of a build. So this directory is a great place for you to put functionality that you might need in every single one of your Gradle builds. Perhaps it's checking something out from source control or kicking off a process to clear out a database. This is a great place for it. Back in our home directory, there's a lib directory. This contains all of the dependencies that Gradle will need, all the jar files, all the plugins that are out here. The media directory is probably not that important for you for day-to-day Gradle development, but it's got a list of Gradle icons, different sizes and resolutions, PNG files. Next up, samples directory. This one is very important. What we're going to see in the samples directory is a list of all the different templates and examples for various languages like Groovy or Java, maybe working with IDEs like Eclipse, if you've got build tools like Maven, if you've got dependency management tools like Ivy, different languages, Scala examples, working with tools such as Sonar. This is going to be a great place for you to come and reference. Now, again, these are samples. You can, you probably don't need to change these. I wouldn't recommend changing them because it's documentation over time. If you should have the need to modify, please copy this out to a different directory and make the changes there just to protect yourself. Back up in our root, last but certainly not least, the sources directory. Now, this is obviously the source of Gradle. The advanced users may want to come in and modify this for your needs. Keep in mind this is an open source Apache 2.0 project. To give you an idea of what's out here, let's find all of the Java files. And let's get a count on them. 3,439 Java files, and or Groovy files, there's 428. You know, this doesn't mean a lot except to say that there is a good deal of architecture and code behind Gradle. It's complex. It's got a lot of power out there. So congratulations on choosing this tool. Well, that brings us to the end of the things that I really wanted to cover in this directory structure talk. So let's move on to the next section. Thank you very much. Okay, now that we know what's in Gradle installation, let's take a look at a Gradle project. I'm going to go to my home directory, or if you've noticed, this is Ryan's machine, so I've gone to his home directory. I'm going to create a directory for Ryan. We're going to call it Gradle sample. And we'll go inside this directory, and we're going to run the Gradle init command. This creates a sample project for us. You've seen that we've done this before to test out our installations. What's in here? In this basic file, basic sample project, we're going to have a couple of files like build.gradle, and this is where we'll write our Gradle code for our different builds. There's some Gradle commands, Gradle executables in here. I'm going to defer that to Ryan right after I finish up. He's going to talk about the Gradle wrapper, and he will be describing all of that. If we look inside the settings file, settings.gradle, this is where we would have some configuration. If your project has many projects within it, you'll specify them here with the include command. You can also set a root directory of the main project here. And that takes us to the end of what a basic project is. It's really small, really quick. Ryan, why don't you go ahead and talk to us about the Gradle wrapper?
The Gradle wrapper. One item you'll see in the default project is the Gradle wrapper. The Gradle team strongly recommends this as the recommended way to run Gradle. It has some upsides and some downsides. One upside is that you don't need to expect the system you run it on to have Gradle installed. However, the downside is that it will install and build up quite a bit of files on the target system. Some have debated are excessive. Either way, you can install and run it as we have laid out here, or let the wrapper do the work. You'll find in our sample project a file called Gradle W, and there'll be a gradlew.bat or a gradlew command line shell script file. So here we've got a .gradlew. Since I'm in Linux, I would just run that. And I can run the same commands I normally would. So I could say gradlew compile, and it will run. And if you look in there, it'll create a file actually called, if you don't already have it, you can run Gradle wrapper, and it'll create this directory called wrapper. And all it does is it has enough to bootstrap the Gradle process to download itself. It's actually in Gradle and then under wrapper. You can see what's in there. And it's got some properties and a jar file there. And you can safely add these to source control, so that would be a really good thing to do in the CI server. So then it would see those things. It would know how to download Gradle and proceed forward with that. And we're going to cover this a little bit further later in the section called Continuous Integration and CI Servers. We'll get into that a little bit later when we do some real-world usage and why the Gradle wrapper is probably a really good idea. To summarize, you should now have Gradle working and installed. You've also learned how to keep up with current versions using GVM and be familiar with what comes with the Gradle installation. We've finished with creating a simple default Java template project to get you familiar with the basic files and structure of a simple project. Tune into the next section for a more in-depth hands-on coverage of Gradle tasks. Thank you.
Welcome to Section 2 of Effective Gradle Implementation, Gradle Tasks. In this section, we will learn how to create tasks in Gradle and reuse what you can of old Ant builds if you wish. At the end, you should understand enough to get a basic taste of Groovy syntax and creating a task. The list of topics that will be covered in this section include building with Gradle, the build.gradle file, running and adding basic tasks and default tasks, a taste of Groovy, using the build file to create tasks and dependencies, and also a quick language primer on Groovy, dynamic tasks, using the API to access tasks, using Ant tasks, really important to make sure that we get some reuse out of our old existing Ant tasks. And finally, using the DAG to check runtime tasks. In the last section, we saw how you could run the Gradle init command to generate a project. We've already taken the liberty of generating a project. Let's go take a look and learn a little bit more about build.gradle and how things are working. Oh, wait, one quick disclaimer. You're going to see a lot more in the build.gradle file than we're going to be talking about right at this very moment. Please be patient. I promise that as the screencast goes on, we will cover everything. Thanks. Now onto the good stuff. All right, so as I mentioned, we've already created a project. You'll see there's a build.gradle file out here. There's also a source directory. This was originally created, if you can tell, by the pom.xml. This was originally created as a Maven project that we converted over to Gradle, and you'll see that in the directory structures. It'll just make it a little bit easier to talk about. So let's go and take a look at our project. Now, we are going to want to build several artifacts. For instance, we're going to want to build a core jar file, which is going to consist of our core classes. We're also going to want to build a utils jar file, which is going to bring in this hello world utility. Now, each of these artifacts in our application are specified in a configuration. Within these configurations, there are several steps that we must do in order to build the artifact. So let's take a look at build.gradle. Those steps are called tasks in Gradle. So if I look down here, I've got a task for creating my util jar. I've got a task for creating my core jar. We see that there is also a step to compile Java code. That's going to be a task. Here's another task that we will use to build the jar file of our compiled classes, as I mentioned, the core.jar. Now, I'm sure that you'll see that everything we have here in the build.gradle file is code. In fact, it's Groovy code that the Gradle framework will utilize to perform the necessary actions for your application build. With all of this build in complex environments, it'll be necessary to bring some order to the chaos. So let me show you how that is done with a task dependency. Here in our core task, we are saying we're using a depends on, and we're listing other tasks that must be run first. So if we were to run our Gradle build with a target of core jar, clean and compile Java 1 will run first. Likewise, if I try to run with a target of util jar, then compile Java is going to run. There's not going to be a necessary to run clean. Now, I'm going to go ahead and turn this over to Ryan, who's going to a little bit more detail on build structure around build source, and then go into depth on the Groovy code and structure you are likely to see in a build.gradle file.
There are many ways to organize your build logic in Gradle. You can write your own Groovy code, inject configuration, build a project, create custom plugins and tasks, build external libraries, or run external builds. One of the easier ways to organize your build is to use the build source project. This pattern lets you drop your files into the build source folder and they'll automatically be included in your build class path. For example, if you put build.gradle in build source, it will automatically be run and tested in the class path. Keep in mind if your project is a multi-module one, only the root project can have a build source folder. The next option is injection. This is where you write Groovy code that uses the less than operator to inject it. Let's look at the user guide sample. We've got here a task show, and inside of there we've got our less than operator, and it's used to inject the code in here. You can see here the task show is injected. This is preferred over inheritance because it's explicit, but also dynamic and flexible. With inherited properties, this is automatic because any child projects will inherit the parent properties. This can be messy and hard to troubleshoot in a complex hierarchy of ancestors compared to explicit items from the configuration injection. As Lee said, the build.gradle file is a series of Groovy closures and code. A Groovy closure is nothing more than a code block or method pointer that tells the compiler to run that block of code at a later time. Groovy syntax is very familiar to Java programmers with less than technical craft. For example, you don't need to end lines with a semicolon. Use parentheses for method calls. And if you use double quotes for a string, we can define expressions with the $sign syntax. The expressions are evaluated when we use the string value. These strings can use variables inside them, similar to a printf statement in C. Let's take a look at the following code. Created a hello task, and let's go ahead and print a line out 5 times. You can see in Groovy, we can just use a variable and use the times command to repeat something any number of times declared in a variable. Notice we don't have semicolons at the end of strings or parentheses in our method calls. And we'll see the output says, I will print, and it says this value, and it goes and repeats it 5 times. Other things to watch out for are the double equals in Groovy is an equals comparison to primitives, which really are objects in Groovy, as well as objects are compared to other languages. You can also safely use the equal comparator for pretty much anything as you would expect it should work. Comparison operator equals safely works for comparing primitive types or objects. Also, to declare a variable, you can use the def syntax or traditional Java type syntax. The def syntax allows you to loosely type a variable as you go. For example, I can declare an integer x equals 0, or in Groovy, I can say def x equals 0. This will allow me to loosely type the variable and change its casting later and give me more freedom for what I can do with it. The def and assignment in that case simply imply the value as an integer, instead of throwing a null pointer exception. Another difference from Java is how you declare arrays. While in Java, declaring an array uses curly brackets, like this example here. In Groovy, it uses square brackets. Keep this in mind. If you're copying Java code to Ant scripts or Groovy scripts or Gradle scripts, and they're using Groovy, you may get a syntax error there. Also, keep in mind that square brackets here uses a Java util array instance class every time you set one of these up. A few other gotchas. Return is optional in Groovy. If you don't specify one at the end of a method, it will return the value from the last line of code. Floating point math always implies the big decimal object. The this keyword can be used in static code sections. Also, keep in mind that most Java core libraries are implicitly included by default. You don't need to specify import statements for them in Groovy or in Gradle. For a comprehensive tutorial of Groovy, read more at the Groovy Getting Started guide. Here we've got the Groovy Getting Started guide. This is a really great resource to run through the tutorials and get yourself further up to speed with Groovy. If you go through tutorial 1 through 6, you'll be ready to go in no time.
You know, one of my most favorite features of Gradle is the ability to dynamically add tasks. That's right. When you're writing your build file, or more specifically, when you're running your build file, it doesn't have to have tasks that exist when you're writing it. Let's take a look at this example here. What I've got is a definition of locales. And then for each locale, I'm creating a dependency closure in which I specify the task is going to be named internationalize with my internationalization code. And what I'm doing is I'm going to be creating a war. So what this does at runtime is evaluate this array that is full of internationalizations and creates tasks for each of those internationalizations. So I can create my own core ENUS war. I can create my core ENUK war. And just by going in later on and adding in something like ESSP, I believe that's the internationalization code for Spanish Spain, we would be able to create a core ESSP war file as well. It's a great feature to allow us to take things that we would do again and again and again with different specifics or different names and just code it all into our build.gradle file in one time and minimal changes later on down the road. Now, with that said, I do want to urge you to be careful using this feature because it may muddle your build file and make it confusing for others to maintain, and all of a sudden appear as if you've got magic variables within your build file.
Thanks, Lee. Now let's cover some basics on using the Gradle Task API to add functionality or dependencies. In Gradle, a single atomic unit of work is called a task. Task can be anything from compiling code, to generating Java docs, to creating a jar file, or anything else that you have the ability to code. Each task is comprised of a sequence of action objects. Each of the actions is executed in the order when action executes called. Tasks due first and tasks due last provide a means of adding actions to tasks. That's a pretty powerful way to control the task flow with regards to error conditions. In any given action, you can either skip to the next action within the task or skip to the next task. This is done by throwing one of two special exceptions, stop action exception and stop execution exception. Let's look at some examples here of those things. Here we've got a stop action exception where we skip the next task, right here. And then we've got a stop execution exception, so something bad happened, we're going to go ahead and not continue running the script at all. So there's the two ways of controlling the flow there with by throwing special exceptions. If a task has been created, you can access it via API. This allows you to add behavior or dependencies to a task progressively in your build file. Let's look at some examples. Here I've got a task hello, and I'm printing out a value 5 times, and I'm using the left shift operator. This is shorthand for do last. Accomplishes the same thing down here, where I have a do last here, so this will guarantee this is run last. And we can also force things to run first with a do first. So, for example, we would skip this task because we throw an exception after we printed the message saying, hey, how do we do some prep work? Another common usage is another option called only if. So here, example, we've got hello only if. So if a condition is true, we'll only run this task. Pretty powerful stuff. Another option to control the flow of the way things run is to use the dependency. So we can say in this example, this hello depends on goodbye sayonara. That means goodbye will always be run before sayonara. There are other cool things you can do, such as get did work and configure and more. For a complete list of the API functions, let's go look at the Tasks API in the Gradle homepage, and you'll get all the information you need there. So if we go here to the task documentation, we've got all the information about how to run tasks, the different kinds of operators, different ways to control execution, different kinds of properties that can be used, as well as variables that are statics, and things like that. So definitely check this page out. You'll get everything you need about tasks to make an excellent Gradle build script.
Let's talk about Gradle and Ant integration. Gradle provides a very flexible integration with Ant since Ant is treated as a first-class citizen within the Gradle framework. If we take a look at my core compile task, we'll see that I am dependent upon a task called compile Java 1. And let's go and take a look at task compile Java 1. I'm calling an ant echo and telling it to echo out the phrase, here is where we are compiling the Java code. What I'm actually doing here is I'm calling an ant task echo to display that message. Let's say that you have a custom ant task though, and it just so happens that I do. As we can see here, check style. Here's how I've defined the custom ant task to be utilized by my Gradle build to run against the code. Sometimes you'll have to have some class path modifications for it to work using custom ant task. As we can see that when this gets called, it's just going to do a print line. I'm using Groovy syntax to print out the statement. Now, another very powerful feature of Gradle is, with integration to Ant, is that I can import an Ant file. This becomes extremely helpful in the event that you want to integrate your code with a developer who sadly isn't Gradle savvy yet. I have my Ant import right up here. And I am setting some path variables and some references to class paths. When you import an Ant target, Gradle treats it just like a Gradle task. So we can call it in the same way we would call a Gradle task, and we can also add in dependencies when it's necessary. But we'll talk about dependencies later on. Do you remember when we were talking about being able to reference tasks that didn't exist, but were created on the fly? Well, how does that happen? Well, as it turns out, Gradle has both a configuration phase and an execution phase. And what's even cooler is that Gradle gives us a hook into that configuration phase via the DAG, or Directed Acyclic Graph. It can be yet another very powerful Gradle feature. So let's take a look at it a little bit more. I have a sample build.gradle file, and let's take a look at what we've got here. I've got a task that I'm calling build package, and in here, I'm just giving a print line to print out a string with a version variable in it. And then I've got a task that says release, and it depends upon my build package task. And I'm printing out a message in there just to let you know that we are actually in that task and we're working with it. Now, if I were to call release, it's going to execute both release and build package. If I call just build package, it's only going to execute build package. That is pretty much granted. But let's look at this last closure I have down here, gradle.taskgraph.whenReady. This is accessing the DAG. And I'm asking the task graph, does the task graph, what I'm executing at this point in time, have the task release in it? Am I actually going to be executing release? If I am, then I want to set version to 1.0. If I'm not, then I want to set it to 1.0 snapshot. And that version variable, as we saw, is up here. So what should happen is if I run build package by itself, I am not running release, and I should have a 1.0-snapshot in my message. If I'm running release, and I do have that within my executing task graph, then I should have a version 1.0 message. So let's actually see that in action. And I'm going to run Gradle. I'm going to use the -Q option, and just as an FYI, this is going to keep Gradle quiet. All the normal Gradle messages and noise about the task we're in, it's going to go away, and it's going to reduce this down to just the print line statements that our build script is executing. Let's run build package. We execute, and again, you can see that because I don't have the release task executing, it says that it's a 1.0 snapshot version. Now, if I do the same thing and actually execute the release task, the version changes. Not only do I enter that task and I can do extra work, but I can change the version. How is this handy? Well, obviously, this allows us to change the behavior based upon just the task structures that we're working on. In this particular case, we can change the version numbers that we're working on to support our development processes. If we wanted to go a little bit further, we can actually change configuration files in there. This example is using tasks that I have explicitly defined. We can do the same thing by accessing dynamic tasks in here. The configuration phase will build the task graph, and then the execution phase will do any of the work that we need to with that task graph. Again, in this case, all I'm doing is just changing a very simple version variable, but we can, sky's the limit. So that is section 2. We thank you for sticking with us through it. We're going to move on to section 3 next. Thank you. In this section, we're going to cover how to build and set up a basic and multi-module Java project. This will publish a .jar artifact. The list of topics that will be covered in this section include Java plugin tasks, hooking into Maven, testing, publishing your jar, multi-module Java projects, creating a distribution, Groovy plugin tasks, and building a war.
Java plugin tasks. Building a Java application with Gradle is very easy. With Gradle 1.11 and later versions, simply use the command Gradle init and it will bootstrap a new Java project for you. Let's take a look again at the generated build.gradle file from this task from previous sections and explain it in a little more detail. Go ahead and run Gradle init. We'll create a fresh project. And look at what it created, a build.gradle file. Let's edit that. And we can see in here, we've got a apply Java plugin and some repositories and a few dependencies. Nothing very exciting here. It will always use the default source directories unless you specified otherwise. So let's go ahead and run Gradle build. See what happens. All right, we can see the tasks compile, jarring, assembling, testing, all these things are being run. You can see that there are main tasks that are run as part of the project. Here's a basic rundown of all of them. Get this list by running Gradle tasks to get a list of them. All right, so here we can say we've got the init, creates a new blank project. We've got the wrapper, we'll generate wrapper code for the project. This allows the user to run without installing Gradle yourself. We'll talk a little bit more about that later. The Java plugin gives you a java.doc command, which will generate Java API documentation off of your source. It's also got some helpers. Dependencies, it will display all the dependencies. So if you're having trouble resolving conflicts with classes, this is very helpful. And there's also a dependency insight, which is also a newer option to even give you further depth in dependencies. And we've got help projects for subprojects, properties, tasks, and we have options to verify the configuration with a check and then the test command. The goal of the Java plugin is to produce a jar file artifact. Plugin is essentially code that extends Gradle and allows us to reuse services and functionality. Gradle plugins can also be written in any language that compiles down to bytecode. You can write Gradle plugins in Groovy, Java, or Scala. Imagine writing logic for your Groovy code and seeing it applicable to your Scala builds, and not having to recompile or rewrite your plugin. Another thing that makes this cross-language, cross-project, cross-build ability very powerful is the plugins have access to common infrastructure of services and access patterns that allow us to not have to reinvent the wheel. The application of a plugin to a project is also idempotent, so no matter how many times you apply it to a project, you won't risk causing any unforeseen results. Enough about plugins. Let's get back to the topic at hand. Testing is already part of the process, and if you don't have any tests, it will skip over that with a success message, although you really should write some tests. Next up, Lee will show you how to hook your build into Maven to bring in dependencies and to get your jar artifact out there.
Building with Gradle is a pretty cool thing, and it can give us lots of power. However, one thing that will help us manage all of this power is dependency management. We're going to talk about dependency management in a little bit more detail later on. Right now, however, I want to briefly cover a way to store the artifacts and dependencies. We'll create these artifacts and dependencies with Gradle by harnessing the Maven repositories, and we'll do that by using the Maven plugin. I happen to have the Maven plugin loaded here. This is the user guide from Gradle, and let's take a look at how we would actually do this. To use the Maven plugin, we will need to add just one line to our build.gradle file, which is the apply plugin Maven. This will by default add an install task, and this install task will take all the associated artifacts as well as any generated metadata and copy it to the .m2 directory. You'll also be able to upload to a repository of your choice or a local Maven repository if you use the upload archives task, which we have just down here, upload archives. The docs are available, so feel free to skim the user guide for the Maven plugin at your convenience. All right, so here at the command line, I'm going to run Gradle tasks. And I want to do this to show that our sample project right now does not have an install task associated with it. So our tasks come up, and I do not see an install task anywhere. Now I will come in and edit it. Let's add that line back in. You can see again, apply plugin Maven. And now let's rerun Gradle tasks. We have our install task, so we're good to go. The next thing that we're going to want to do is to configure the upload archives task. What I want to do is upload the artifact that we generate from this build to a local directory /temp on this computer. So we will edit the file, build.gradle. Happen to know it's circa line 244. And I've already got this configured. You'll see that I am telling it I want it to go to my local temp/Zan repo directory. My group ID is Zan, version is 1.0, and the artifact ID is Zan demo. This is done in the Maven format, so we can exit out, and I'm going to do a Gradle upload archives. It's going to run through. Now, I've not specified in this directory structure, or I've not specified within this build.gradle file a specific target. So it's just going to default to war. We will talk about war files later on in this section. I go into my temp directory, Zan repo. We'll see that I've got a Zan directory. I've got a Zan demo directory. And we've got the beginnings of our Maven-esque structures, our Maven structure. If I look in the 1.0 directory, this is where all my demos are. And again, because I did not specify a target, I have a war file target here. Now let's go back and take a look at our build file again. Build.gradle. Now we can use configurations to configuration closures to define additional configurations in here if we needed to upload to different repositories. Support is offered for the following protocols uploading to a Maven repository: HTTP, SSH, SSH external, FTP, WebDave, and file. Each of these, of course, will require information specific to the protocol. For instance, in using SSH, you would need to provide authentication information. The Maven plugin will also add an install task to the project. Well, let's go ahead and call it. But before we do, note that I've already configured the install task with a configuration closure to specify the group ID, the POM version, and our artifact ID. So if I run Gradle install, it's going to go through one more time just to be specific. We have not specified a war file, so it's going to default, or an artifact type, so it's going to default to a war file. Now, if I go to my home directory /.m2 and look in here, inside my repository directory there, I see that I have a Zan directory with an artifact of Zan demo. I have the same Maven structure and the same contents. All right, let's talk about testing. I'm pretty excited. This is a topic that I'm very passionate about. Gradle has some really cool features that enhance testing. The core of it stems from the test task. Essentially, the test task will discover and execute all unit tests in your test source set and will produce a report of the test execution at the end. Before we get too deep into testing, we need to talk about source sets. Gradle source sets are a way to group Java source and resources in a logical way. There is base functionality for Java, and because the Groovy and Scala plugins extend it, they also add additional properties. Now, I'm looking at the Gradle reference guide and the section on source sets. You can see here's the URL in case you need to get to it. This example is pretty straightforward when we start talking about source sets. In this particular case, this is going to be used for a compile option. And it's telling us that we want to look at our Java code, and there are some classes in a package that we want to exclude from the compile. We're going to use this in just a few minutes to configure our own Gradle test. Now, there are some properties that can be used, like all Java and all source. And notice that these all properties are read-only. They're calculated, and we have to take the values that come to them, not supply stuff to them. If we needed to make changes, we would use our excludes to begin to take files away from that. The test task supports both JUnit 3 and 4, as well as test ng tests. So you should pretty much be covered for all of your Java unit testing needs. But before we look at running some tests, I'd like to point out that Gradle executes tests in a separate VM. The VMs can be configured through numerous options that allow us to change the behavior and the size and the characteristics of the VM. Additionally, we can even specify the number of tests to run before stopping the VM and restarting new tests in a new VM. Trust me, this is a great feature. I can't tell you the number of times I've had heap memory exceptions when running tests, and this is a great way to defeat them. Now, Gradle will scan for tests, and it will scan the class files in the test source and run the tests that meet the criteria for JUnit 3 or 4 or test ng. Of course, this is a feature, and it can be turned off by just setting the scan for test classes property to false. In reporting tests, Gradle will automatically create results in HTML format as well as XML format to be easily digestible programmatically, like for CI servers or other applications that you might have to go and analyze your results. But let's actually take a look at how we can use this within our project. So I've got a couple of unit tests out here, index action test and hello world action test. I'm going to go and take a look at our build.gradle file. And you can see that I have defined the source set. I'm telling it I just want to go into my source test directory, grab everything that's there. So it should grab both of my tests. Notice that I only have test in my build.gradle file twice in these two places. I'm not actually defining any test tasks. What I'm going to do is just utilize this closure to configure based upon my source set, the files that I want. I'm going to take the default test tasks that I'm getting from Gradle. So if I come out and do a Gradle test, we're going to run, we'll get our test, we're going through all the phases. You can see that we hit our test class, and I want to run over to my build directory. If I look under the test results directory, what I see is the plain raw HTML for the test execution data. If I come back up into my build directory and look at reports, tests, I've got an index file here. And this gives me the HTML version of my report. So I can see that I've got 2 tests, no failures, nothing ignored, only took 18 milliseconds. And if I come down, both of my tests ran. I've got one for Hello World action test, and I can drive down into it to get down to the fine-grained details.
Multi-module Java projects. Up until this point, your Gradle build file has been fairly simplistic for a single artifact and codebase. Now let's dive into a more complex project where you have multiple codebases and code trees that need to combine into a single artifact. You can accomplish this by using the multi-module support using the include directive. You can set up each codebase as an individual Gradle project like the example above, but designate one project to be the master. You can accomplish this by using the include directive in settings.gradle. Now let's go ahead and look at a sample settings.gradle file. We see here we've got basic syntax that says include subproject. That's all you have to do for it to know that this directory called subproject is now a child project of the master. Once you have included the subproject project in your parent project, you are now able to reference it in your build.gradle file, like so, in the following manner. Here at the bottom of our example file, we've got a multi-module project reference. And inside of a closure, we declare below here, we've got a task called list projects. And you can reference that with a project command, and then you just specify in single quotes, colon, and then the name of the subproject. This will go ahead and apply this task to run, it'll tell the subproject to run list projects closure from the master. So when we go ahead and run that, we'll see the output that it actually takes effect. This is a great way to dynamically add tasks to subprojects without having to copy the code around multiple times. So we see here it says, I'm a Gradle web app, subproject, list projects. Now we're inside of the subproject. It says, I'm a subproject. So it identifies what its name is to the master. Because build scripts for a project in Gradle are optional, you don't have to put a build.gradle file in each subproject of a multi-module project. If you have build.gradle files in your subprojects, you can skip the above code example and just start using tasks defined in other projects. You can always reference tasks by specifying the project name and dot notation in the task. Use the name you included, for example, subproject.listprojects, to run a task from the parent project of the subproject submodule. Another approach would be to specify common things in your master project file to keep your subprojects cleaner. For example, you could specify global properties in your master project file that would inherit to the child projects. Creating a distribution. At some point, we will want to distribute this application. Gradle offers us the distribution plugin to help us out with our needs, like with the Maven plugin. It's quite easy to use the distribution plugin. We just need to apply the plugin distribution to our build.gradle file. This plugin will add into our project the diszip and disttar tasks, which will take distribution contexts and package them into zip files or tar files accordingly. Well, what are distribution contents? They are anything in source. Under distribution name /dist directory, you can add in extra content by configuring the distribution object. Let's take a look at how this works in our build.gradle file. You can see here I'm creating a core jar archive from all of the files in my core distribution. Verify this by dropping to the command line and looking at the contents of the zip file created. So let's go ahead and do that. Go ahead and run Gradle core dist zip. You can also run Gradle core dist tar. So let's go ahead and look at the file it created, which is core-1.0.zip. You can control the version and names on the DSL for the distribution plugin. All right, so we see here we've got our class files. I've included and excluded parts of my source, so I only get anything under comzan, but not comzan util, which is reserved for our util jar task. Before we go to talk about multi-module Java projects, let's spend a few minutes talking about the Maven plugin in more detail, since it extends the distribution plugin. There is a newer, better version of the Maven plugin called Maven Publish. The full documentation is in the user guide. This plugin is better in some ways, but it has some issues that is considered incubating, which means it is subject to change without notice in future versions. This plugin extends the publishing plugin. This plugin assumes you understand those concepts that are laid out in the Gradle artifact management article. Check the slide here for the link. We will also cover it in more depth in section 9 of this video guide. To get started using the plugin, simply add this definition to your build.gradle. Apply plugin Maven Publish. To add a Maven publication for a Java object, let's look at the example in the user guide. here we've got publishing closure, and inside of that, publications. Inside of that, we have Maven Java, Maven publication closure. And in here, it's got from components.java. That means it's going to use all of the components from the Java plugin. This example will add the artifacts and runtime dependencies from the Java component set up in the Java plugin. Notice the second group, source jar. This is showing the ability to add custom artifacts to your publication. This example takes the code sources and adds them to a jar, so you can make your IDEs provide better editor hints, Java docs, and suggestions. You can also modify the POM that is generated, publish multiple modules, dry run of the POM file, and publishing to Maven local. We cannot cover this topic in depth due to time constraints, but check the user guide link for more information. Next, let's set up our repositories. This is similar to the older Maven plugin. Again, let's look at the user guide example. Here we've got a regular repository section. Inside there we have a Maven closure. Inside of there, we've got a URL. We add this to the build.gradle and point to your repository. These are the same parameters used when consuming Maven repositories, except you can publish to them. The same properties are used from there as well, so for authentication and other details, see repositories in the artifact resolution section and the links at the end of the section. Earlier I mentioned there are some bugs with this plugin. For example, there are issues with installing snapshots to the Maven local repository. If you're using snapshots, this may be a deal breaker for you. See more info at the link provided at the Gradle bug. It is also fixed in version 1.9 final release. In conclusion, for creating a distribution, I've posted some useful links here that you might need on how to use the plugin. Distribution plugin links are here, the Maven publish, the concept of artifact management, which is very important to read and understand why you do the things we do with artifacts, and also a little bit details if you're running pre 1.9 of Gradle, the snapshot bug. Groovy plugin tasks. Gradle not only works for a Java project, but for a pure Groovy project as well. Let's take a look at the generated build.gradle file. In the section applied Java plugin, we'll just change that to apply Groovy plugin. So we'll go ahead and here and find the Java plugin, rename it, and we're good. You can also simply add the Groovy plugin or replace it, because the Groovy plugin also extends the Java plugin. Next, let's add the Groovy library dependency to your project. Specify the version of Groovy your project uses. Now keep in mind, this is different than the version of Groovy that's built into Gradle itself. We jump down to the dependencies here, and in this project we've got the org codehouse Groovy all jar, which will basically include Groovy for a Java project. And in this case, we've got version 2.0.5 of Groovy, or whatever version you want to run should work just fine. You will add this and any other dependencies you have. Now, when you run Gradle build, your Groovy source files will be compiled into your jar. That's it. There's one other difference between the Java plugin. The additional target is available called Groovy doc. All this does is runs docs in the traditional Groovy doc format, which are a little bit more decorated than the Java doc format and that the Java plugin uses.
Okay, let's make some war files. We're going to use the war file plugin. As before, it takes just a single line in our build.gradle file. So what we'll be doing is applying the plugin war. This will give us a war task, and that task will create a war file for us. I know, pretty straightforward. By default, it will copy the contents of source main web app to the root of our archive. It'll also look for any compiled code and put it in webinf classes. All runtime dependencies are going to be copied to webinf lib. So let's actually take a look at that right now. So in my project, if I look at my build.gradle file, you can see that I already have the war plugin applied. So I'm going to come back out to my command line, and I'm going to run Gradle war. It's going to run our build, move all the projects around, create our archive. Our build was successful. So if we go into our build directory, into the libs directory, we can see that our files here. And Gradle has taken the name of the project, Gradle Web App, default value of 10. It's a war file. Now, war files are just zips, so I can use the unzip tool to go and take a look at the contents of this. And what we can see is that there are indeed compiled Java classes in WebInf classes, that my jar files, my runtime dependencies, are indeed in WebInf lib. And everything here looks like it's all set up. I can see that my JSPs are in the right place. Now, what if I wanted to change these around and not necessarily put everything that was in my source main web apps folder in to the archive, or I wanted to pull in a different web.xml file? How do we do that? So we're back at the Gradle user guide, the War plugin documentation. If I scroll to the bottom, there's a great example of doing those customizations I talked about. Here we can see that this particular WAR file is going to have content that is not derived from source main web app. There's a new web.xml file that is some other file. There's configuration in here to change the webinf directory to add more libs into our webinf lib directory. All of the customizations that you can do are going to be documented underneath the WAR API. And we can see that there is a great list of properties here. Please feel free to change these up and experiment with these to build the custom WAR files that you want. But let's take a look at how we're doing it with ours. So inside our build.gradle file, I've created a task called our WAR. And in here, I've already told it that I want to build my jar file for a core library. I'm just making a couple of changes, like the name of the WAR file, the version number. I'm pointing to a different XML file that I want to use as my web.xml file. Now, if I had a need to create, let's say, a QA WAR file and a prod and a dev WAR file, I can create different tasks for QA WAR, prod WAR, dev WAR, and just change out the WAR file or the web.xml directory, the web.xml file that's in question, or even different resources if the different environments that I'm running in requires different resources. Let's go run this. Gradle our WAR. We're going to do the same exact things that we did before in terms of building the WAR and copies and such. However, the differences are going to be the name of the file, the version, and the web XML. So if I go and look at my file, already I can see that two of those changes came into play because I have a version of 1.0.0 and the name is effective Gradle. If I open this up, all my classes are in the right place, my runtime dependency. There is a webinf/web.xml file. This is different than the one that I had before, and it's just that inside the name, by convention, the WAR file is looking for web.xml. So even though I copied it from prod/prod.xml, the WAR task is going to change that name for me. Well, that's it for section 3. We talked about Java and Groovy plugin tasks. We hooked into Maven. We talked about testing. We looked at multi-module Java projects, created a distribution, and built a WAR. So coming up section, we'll talk about IDE integration, and that'll be great because I don't know about you guys, but I'm getting tired of using VI, and I would love to actually have a great IDE to play with for the rest of the screencast.
IDE integration. Let's get to making Gradle easier to use for you. In this section, we are going to talk about the IDE integration. We'll start with IntelliJ, and then Eclipse, and then finish with Netbeans. Let's start with IntelliJ IDEA, which has the richest Gradle support of the three. In this section, we're going to look at IntelliJ IDEA. For the screencast, we're using IntelliJ IDEA 13.1.1. Previous versions worked differently and used a plugin called Gradle. It is now seamlessly built in on 13.1 and higher. The first thing we'll need to do is turn on the Gradle plugin in IntelliJ. It's pretty simple. Let's go ahead and do it. The first thing you'll do is open the IntelliJ preferences and go to the plugin tab. If I don't have any project open, I just can click on Configure Plugins. Find the Gradle plugin, check the box, apply, and restart. Now that IntelliJ has restarted, we are good to go. Let's go ahead and open our sample project of our Gradle example here. and take a look at what we've got. IntelliJ support is fluid enough that will detect that this is a Gradle project and automatically download any necessary dependencies, including Gradle, for you. It'll also generate an IntelliJ project file as well if you have not opened it before in IntelliJ. Now let's look at the tab we have after turning on the plugin called Gradle. Let's go ahead and run our compile task by double-clicking on it. And we see that our build is successful. It's that simple. If you've run any task previously, you will see the history here. If you've run a task by double-clicking on it, if you right-click on a task, you'll see there's another option for running it. So, for example, we go to compile. We can see options for setting profiles, saving a profile, running it, or debugging it as quick access tasks right there, like most other projects in the traditional Ant support or Maven support. Dependencies are managed like any other project dependencies in the Project Structure tab. So if we click on Project Structure here, we can see that the Gradle support is automatically managing the dependencies and detecting them as part of our Gradle build and showing them here. Another cool feature of the support in IntelliJ is the auto-completion. So I can manage not only from the Project Structure tab, but I can also go into the dependencies inside of the build.gradle file and get auto-completion checking. For example, I can go in here, and if I want to say, oh, maybe I want a different version of JUnit, I just do my tab control space completion here, and it'll automatically find dependencies for me. So if I'm not sure what version or thing I need to include for a dependency, the auto completion will help you find it automatically, which is really, really nice support if you're trying to find the right dependency for the right thing. This also works for plugins as well. So if you're not sure of the plugin name, you can always do auto completion there as well, and it'll tell you all the matching plugins that you can use for Gradle. This is a really handy feature if you're not sure what to do. And that's the IntelliJ support for Gradle in a nutshell. Its support is the richest of the three here we'll talk about tonight. And next we'll talk about Eclipse with Lee.
Okay, moving on to Eclipse. The first thing that we need to point out is the fact that, as Ryan mentioned before, the Gradle integration for Eclipse is not as rich as it was in IntelliJ, but we will do what we can to get some integration here and give some functionality from within Eclipse. If I start off by installing the plugin, I can go to click on Help, Install New Software, as you typically would with Eclipse. I'm going to create a new repository that I'm going to call Spring Source, and my URL is going to be http://dis.springsource.com/release/tools/update/e4.2. As a quick aside, if that URL isn't working for you, then you can come to spring.io/tools/ggts/all, and towards the bottom there's a section for update sites, and you can use one of the latest versions that are out here currently in production are 3.7, 3.8, 4.2, and 4.3. Back to Eclipse. So I've added my source. I'm going to say that I want to install the Gradle package, and we're going to carry through with the way that we would normally install the rest of our Eclipse plugins. So I had to reboot Eclipse after installing that plugin. Let's make sure that the plugin is here. If I go to Window, Show View, Others, you can see that I've got a Gradle's tasks view here. So let's go ahead and open that up. And it is here. Gradle is actually integrated with Eclipse at this point, but what we really need is a project to work with. So let's go to File and Import. We can see that we're now given an option to import a Gradle project. Let's do that.
I'm going to import a project that I already have created. To do that, I will click the Build Model button, and it'll go out and analyze the project, the build.gradle file, and show us all the projects and subprojects in here. My Section 4 project has been selected by default, so let's go ahead and finish that up. And if I come back to my Gradle tasks view and refresh the task list, I now have Section 4 loaded in, and all of my tasks are here. So let's go ahead and just click one and run it. It runs. So at this point, we are set up with Gradle with inside Eclipse. That integration is going, and we can begin to do some work.
Netbeans. First of all, let's talk about how Netbeans handles projects differently than Eclipse or IntelliJ to explain why certain behaviors are the way they are. Netbeans doesn't use a project file per se. Instead, it reads the build script of the project and proceeds to act from there. This is a bit of a catch-22 because as of Gradle 1.8, support added for Netbeans, which is the only released version as of in the initial writing, forced you to write your build.gradle file in a certain way. After 1.9, there were issues resolved with Gradle and how Netbeans required you to structure your project. That is, logical source trees had to match physical ones. Starting with Gradle 1.9, these issues are resolved and support is improved for non-standard, not really a thing in Gradle in the sense like Maven or Ant. To help frame the advice as of final editing, Gradle 1.11 has been officially released. Let's navigate our browser now to the Netbeans website. We're going to click on Plugins from the home page here. Scroll down, search for Gradle. Click on Gradle Support. Pick our Netbeans version. We're running 8 in this case. Click Download. All right, now we're ready to install it in Netbeans. So inside of Netbeans here, from the main menu, we either do this handy shortcut, Install Plugins, or we can go down to Tools, Plugins, and here's the tabs. We have available plugins. These are the plugins that are already in the repository. You can search and install them from there. Downloaded for things you've manually downloaded, like we did in this case. This is really handy if you want to have the latest cutting-edge version of the plugin. You can manually download that and add it here before it's available in the main plugin portal. So we'll just go ahead and click Install. Select the terms and run. Okay, now we go ahead and click Finish. And we're ready to use the plugin. Go ahead and restart your Netbeans. Sometimes it doesn't auto-prompt you to restart. So let's open our sample project. You can see that Netbeans will automatically recognize our project as a Gradle project and open it for us. To see your tasks, go to Projects, pick your project name, right-click, and go to Tasks, and you'll see all your tasks available there. So let's go ahead and run one. Say compile Java. We're running the Gradle thing. All right, up to date, build successful, everything is good. So now we're ready to use Gradle support. Another important item to note is Netbeans handles subprojects a little differently than other IDEs, and that it requires a build.gradle for each subproject off the root project, or will not be able to build the subprojects. The advantage of this is that you can open subprojects on their own if you're just working in the area and build them without rebuilding the master and all subprojects for small possible changes. Netbeans has some quirks. We mean it inherits underlying Ant and Maven quirks by default. It will expect your project to have tasks named build and run that are optional. Since Gradle 1.9 support is improved, you may not need to do these things. That's it for Section 4 covering IDE integration. In this section, we looked at how to set up 3 popular IDEs for Gradle use. We covered IntelliJ IDEA, Eclipse, and Netbeans. We hope that regardless of your personal preference for your development environment, you can take away from this section some value that will help speed up your development using Gradle.
Welcome to Section 5, where we're talking about dependency management. In this section, we're going to take a look at what is dependency management, dependency types, declaring dependencies, external dependencies, particularly Maven and Ivy repositories, publishing artifacts, and dependency configurations. What is dependency management? Dependency management is the ability to take a list of artifacts your project needs and make them available to the project both at compile and runtime. Let's say that you're creating a web application using Apache struts. That would be something that would be needed both at compile and runtime.
What if your application, though, ran against a different database in your QA environment than you ran it against in your production environment? Perhaps you would need a different database driver. This feature isn't automatic in Gradle, and you have to work with your scripts to get this functionality, but at least it can be done. Be careful to consider that scopes in Maven, such as provided and runtime, would need to be emulated with configurations in Gradle. Gradle will allow you to specify different dependencies at the various stages of the life of your product: compile, test, deploy, etc. I would also like to call out that Gradle uses dependency configurations to group sets of dependencies in order to help manage them. This is good because you don't have to call out each and every dependency in multiple places, and instead refer to the configurations in your scripts. Let's take that struts example. Struts is not a project where you download a single jar file and you're done. Struts itself depends on other jar files as well, or it has transitive dependencies. Gradle will enable you to specify your dependency of struts, and it will not only take care of finding the jar and downloading it if needed, but it will also take care of the transitive dependencies as well.
Dependency types. Gradle supports 6 different types of dependencies. They are external module. This dependency is a module that exists outside your build, in a repository someplace. Project. You can use this dependency to depend on another project in the same build. File. This is a dependency on file in the local file system, for example, local disk or a Maven directory. Client module. This is a dependency on an external module where the artifacts are located in the same repository, but the meta information about them is located in the build file. This allows you to override the metadata for the module you want to use. Gradle API. This is a dependency of the API for the current version of Gradle that you're using. Use this dependency when you're developing custom Gradle plugins and task types. Local Groovy. This is a dependency on the version of Groovy used by the local version of Gradle. You'd use this dependency when you're developing custom Gradle plugins and task types. For example, you can't use your own version of Groovy in custom plugins because you're bound to the version of Groovy that Gradle itself uses.
Declaring dependencies is just as easy as putting in a dependencies configuration block. So as we can see right here from this very, very simple build.gradle file that I've got, there are no dependencies configured. Well, let's go ahead and put one in. We will begin by adding in a dependencies section. Now, if you'll remember before, I was talking about doing compile time and runtime dependencies. What about that one to struts? Let me go ahead and add that in. And my typing is a little bit slow right now. We'll try that one more time. That compile time dependency to struts. So again, I'm specifying the phase where I need the dependency. I'm highlighting the dependency and the version, and it's group ID, artifact ID, and then version. Now, compile says that this is a compile time dependency. That's going to imply that it's also a runtime dependency. What if I actually want to do some testing? Well, if I'm going to do some testing, I will probably want my JUnit framework in there. So I'm adding in a test compile dependency, one that's going to be executed or include the dependency in the compilation of our tests. That is to say, we must have this dependency in order to compile our tests. We talked about project dependencies as well. I could set a compile time dependency for a subproject. As Ryan was talking about with project dependencies, it's a matter of project, and then inside our single quotes, we are going to add in the name of the subproject with a colon in front of it. We can also go much, much further with the dependencies. We can add a runtime dependency in here with files. This is telling us that for runtime, we cannot run our application unless we have included a dependency for a.jar and b.jar. We can list more of these files out as necessary. Check out the user's guide. There's more information about dependencies, but this is a quick down and dirty on how we can put some dependencies into our project. Thank you.
External dependencies. Most of the external dependencies we use in our projects will be stored in Maven or Ivy repositories, Maven being the more common one. You can choose to support both or none of these. Maven is the most popular, mostly due to a larger community and better support through Maven repository servers like JFrog's Artifactory, Bintray, Archiva, or Nexus. Gradle supports both Maven and Ivy repository formats to include dependencies in our project. Also supported is a Maven snapshot, and in Gradle terms is called a dynamic version. Let's start with Maven support. You can use the external dependency most commonly in two ways. You can use a POM builder, which we'll show you here. We've got the URL. Or you can use the long or short config option. Let me show you the docs on doing a customized POM builder format. So here we've got the documentation for the Maven plugin. And then here we've got someone doing a custom POM generation here. So here's a good example of that, where someone's saying, create POM project, put a license in there, and you can control what's going on if you have some sort of special needs. Most common way, though, is to use a long or a short format in the dependencies section. So let's go ahead and show you that in a code example. Here we've got our dependencies closure, and we've got an example of a long format and a short format. The long format uses group, colon, and then name, colon, and then version, colon. The benefit of this is you can put them in any order you'd like. Or you can use a short format. It implies group is first, and then name, and then version. This is the most commonly used format that I've seen, especially in Groovy and Gradle's projects, just because it saves typing. But use whatever's more familiar to you. If you want Gradle to use your native POM XML file without reformatting it as above, you have to declare it as an external module and reference it from an external Maven repository. Once the external module is defined, it will look for a POM XML, or in the case of Ivy, an Ivy XML file. You can even specify a separate location of the POM Ivy file from the actual library it downloads. For more information on declaring an external module dependency, we'll take a look at the documentation for the API and module dependency. So here we've got the API docs for module dependency. So it shows us how we can directly manipulate how these dependencies work and give us more information on how to include them. You can do things like exclude, include, change what artifacts are there, and set transitive or non-transitive properties. So definitely take a look at that if you're trying to use intact POM files that weren't generated by Gradle or anything else like that. To declare Maven or Ivy repository, your build file should look like the following. Keep in mind you'll still need to configure Maven or Ivy repositories in our build.gradle file. So let's take a look at an example of that as well. Here we've got a Maven repository, and we can specify a URL here in a Maven closure, or in Ivy we can also specify a closure. Here we can specify the URL of where the repository is. This section with credentials here, we can use it on both the Maven or repository sections for Maven or Ivy. So if you need to, you have a username and password to access any artifact, you'll need to go ahead and include that there. You can also use the traditional Maven Central as a method to shortcut the main Maven repository, or if you use the Bintray plugin, you can actually reference JCenter by itself. However, this JCenter alias won't work unless you've added the Bintray plugin here at the top. If you don't do that, you'll get an error because it won't know what JCenter is. To see even more, you can include dynamic Ivy layouts. To do so, let's read up in the dependency management section. Here we've got the dependency management documentation, and here we can do complex Ivy builds, control the transitive properties, and support for custom definitions. So if you're doing something non-standard beyond just finding jar files in a Maven repository or Ivy repository, then definitely take a look here for more advanced topics that we're not including in the video here.
An important part of dependency configuration is also being responsible for publishing artifacts, or the things that we build in our projects. Now, let's go and take a look at our build.gradle file, and we're going to see just how we do this. First of all, we can publish using Maven or Ivy. If we're going to publish with Maven, we would need to apply the Maven plugin. If we're going to publish with Ivy, we need to apply the Ivy plugin. Ivy publish plugin. Try saying that 3 times fast. All right, so if we look down at the repository section underneath our upload archives closure, we'll see that there's a corresponding Maven configuration. And in this, I've specified a repository. I'm just setting this to a local file system repository. I've also gone and opted to provide a group ID, a version, and an artifact ID. On the Ivy side of things, I have created a URL. I'm sending this to an external system. I've got some credentials I'm adding in here. The Gradle Users Guide is going to be a great place to go in to get more information about the properties that you can configure for each of these plugins, but that's pretty much it. Now, just real quick, one word of note. If you're using the Ivy flavor, keep in mind that Gradle will create and upload the ivy.xml file for you. If you've used the Maven plugin, Gradle is going to create and upload the pom.xml file for you.
Dependency configurations. Dependency configurations particularly apply to the Java plugin and plugins based on the Java plugin, such as Groovy, Rails, or Scala. Best way to think of this is scopes for your application. The Java plugin adds 4 of these configurations in our project. They are compile, runtime, test compile, and test runtime. These let you declare dependencies such as servlet spec jar for compile, but wouldn't include that in your runtime because in the context of a Java web application, your container would provide it for you. It is important to remember that the runtime configuration extends the compile configuration, so all dependencies defined in the compile configuration are also in the runtime configuration. The cool part of Gradle is that we can add new configurations, or plugins can add new configurations not listed here, that can apply to a certain type of use case. For running test suites, the 2 configurations, or scopes as I like to call them, borrowed from Grails and Maven, are test compile and test runtime. Like compile and runtime configurations, these are the same for tests only. You don't want interfaces creeping into your test runtimes for integration tests. It's important that you don't package up your test configurations or libraries when you make an artifact for distribution or runtime. The tests are important, but only for building and testing a project, not for the end user to run it. Please don't put test configurations in the compile or runtime tasks. You can also specify custom configurations by declaring them in your build.gradle file. Let's look at an example from the user guide. Here we've got a configurations closure, and inside of that, we've got a compile closure and a runtime closure, and then we also have our own configurations.compile closure. What's going on in the example here is that we're customizing the runtime and compile configurations and adding properties and a description. Here one description is that, and another one is transitive. Transitive means it will depend on libraries the dependencies also depend on. If you have jar or library conflicts, you may want to set this to false for more control. We also see they define runtime configuration extends compile, so it would run compile before runtime. Finally, they add a property for a description to see how flexible the API is.
The dependency management section. To summarize, we've covered the 6 types of dependencies supported by Gradle, how to declare dependencies for internal and external types, how to deal with Maven and Ivy, and how to declare and configure them. You should also have an idea about how to publish an artifact to your Maven server. The next sections coming up are going to be specific to certain languages like C++ or JavaScript or Scala. Stay tuned.
Section 6, C and C++ support. In this section, we will jump into building native binaries with your Gradle scripts. This is an emerging area in Gradle and is to be considered an incubating phase. With Gradle 1.9, there are some changes to the plugins. We'll cover Gradle 1.8 C++ support and spell out the differences with 1.9. In a nutshell, 1.9 C++ support is much better, with features like build variants, automatic compiler discovery, separate C assembler and C++ plugins. We'll go over supported platforms, plugins, libraries, executables, go on into tasks, and talk about configuring, compiling, and linking on Linux and OS X, and then on Windows, and then cover external dependencies.
Gradle supports compiling with G++ and Clang on both the Linux and OS X platforms. However, if you're specifically on the OS X platform, you've also got support for Objective-C. Hello, iOS developers. Now, to run and compile on Windows, you can use MinGW, G++, or Visual Studio to get the job done. You can even get a free version of Visual Studio called Visual Studio Express 2013 for reaching your Windows 8 users. As far as native language support goes, as of Gradle 1.11, There is native language support for C and C++, as well as Objective-C. And, you can't get any more native than assembly, so there's that.
Let's get started by looking at an example program that comes with Gradle. Let's go into the version 1.11 samples directory under native binaries C++. Go into our Gradle home directory, samples, native binary C++. All right, take a look in the build.gradle file here. Notice we are applying the C++ plugin. That's the very first line at the top here. Let's keep in mind that it now supports a lot of things you'd expect, like variants of platforms. It can also do dynamic behavior, detect the toolchain to compile, create executables, shared libraries, and static libraries. If you have a simple C++ project that only builds an executable or a library, these plugins help simplify the task. The example provided by Gradle gives you a mix, showing you how to build a library and an executable. In version 1.9+, the plugin chain is streamlined, and there are separate plugins for assembler, C++, and C. Let's build the project with available tasks and run the main executable task to create a executable program. Let's run Gradle tasks, see what we have available to us here. There we go. And we see the main executable. Let's go ahead and run that and try to run the program. Okay, success. Let's go ahead and look in the build directory and try to run our executable. It's under binaries, main executable. All right, and we've got hello world. Now, if you don't have your library path set up, you may need to do that. And by doing that, you could do commands such as export here in the library path and make sure and include the hello shared library. If I didn't have that, what would happen is I would get an error trying to run it. So what if I say, if I get rid of my library path and then try to run it, it'll get an error. All right. Now I go ahead and set my library path correctly. I can run the program. So just keep in mind that if you try to run your binaries, they're not going to be in your library path probably by default. So you'll need to make sure you either have a script or set your environment variables correctly for your shared libraries to actually run the examples. So now we've got a Gradle build script here, building native C++ applications and libraries.
Hey Ryan, good call on mentioning that stuff for shared libraries. What if we wanted to build our own shared libraries, though, so that we could have some good code reuse or just some good old-fashioned clean organization for code and architecture? Well, let's go into that same sample subcode that Ryan was looking at earlier. Only this time, I want to look at the C++ lib directory. And let's take a look at the build.gradle file. The next closure we're going to look at is libraries. Here, we declare what libraries the build will create. You can create closures inside of the library by giving the name of the library and passing the options to it. So in this particular case, we're building a library that we call main. You can also pass options like declaring environment variables, switching toolchain parameters, and that's basically what our build.gradle would look like in a nutshell to build the library. Let's head out to the command line, and we're going to run a task called Gradle main shared library. This is going to execute the task that's going to build the shared library for us. And it was successful, so you'll see that we've got a build directory, and it is in the same structure that we had before. Now, if I go into my binaries, I'll see there's a main shared library directory, and within it, there's my libmain.so. This is going to be the shared library that I will be able to take and import into or link against for the rest of my applications. And there's libraries.
Executables. Let's jump to the C++ exe example and show you some examples of using executables. So we're going to go back to the native binaries samples directory, and this time we're going to go to the cpp.exe folder. Let's go ahead and pull up the build.gradle for this one. Here we've got the executables closure. And if you want to control certain behavior for certain binaries that are built, you want to put them in executables closure, which would wrap the name of your binary inside another closure inside it. In this case, we've got a main here. Let's break this down a little bit further. What's happening is in here, for all of your binaries in your main application, you want to check to see if the toolchain compiling the project is GCC. Note the value you use in the script is camel-cased. It is not what the command is when you run it. If that is the case in the script here, we define a variable that can be inspected later for controlling direction. We can also define or change the compiler arguments. This is critical for making your project compile on multiple platforms. For example, you can expect the toolchain environment variable for values like Visual C++ or GCC or others. So in this example here, we've got GCC is the toolchain, and we set up our compile arguments. So once we've got that set, we can run the main executable target, like we did before. And everything runs as normal. You look in the build folder, and we've got our binaries and our main executable. And we can just run our hello world example again, and we're ready to go. And that's executables.
Obviously, the tasks we have when we're building native binaries are going to be different than when we build Java projects. So if we run Gradle tasks, we're going to see a different set of tasks. Let's go ahead and do that right now. Bring up the command prompt. I'm going to go into the same native binaries directory for samples we've been looking at for the assembly and native builds. I'm going to look at the C++ build file. And if I run Gradle tasks, again, we're very familiar with this. It's going to give us a list of tasks. So let's see which ones are C++ tasks. We've got our build tasks here. These are different than what we've seen with Java projects. Here we've got an assemble task to assemble the outputs of the directory. I won't read every single one of these to you, but we can definitely see that we're going to get something for shared libraries, something for static libraries, and we're going to get something to install an executable and something to assemble an executable. Well, where does all this come from? Not everything that we code in C is going to have the word hello in it. And not everything that we code in C is going to have a main in it. Well, at least it's not going to be named main. So let's take a look at the build.gradle file. And we can see that there's a libraries closure. We've seen this before, and the libraries closure is going to give us those two shared object library tasks and static object tasks. We've also got a main. We find main down here in our executables, and that's what's responsible for giving us the main binaries. If we were to go and add in another library, and while we're at it, let's go ahead and add in another executable. Save that, and go back and run Gradle tasks again. What we're going to see is that Gradle is going to inspect our build.gradle file, and it's going to give us the tasks that are associated with those closures that we put in here. So now we still have hello shared library, hello static library, but we also have world shared library and world static library, the other library that I put in the library closure. We still have install main executable and main executable, but we now also have submodule executable and install submodule executable. That was the other executable I just put in as well. So again, this is going to dynamically generate a lot of that for us. Each one of the artifacts are going to be created in the build directory of our project home. So if we come down and look at our build directory, we're going to see that we get a binaries directory, an object files directory, and a temp directory. The first two are for use when we're setting up and publishing the artifacts later.
Compiling on Linux, OS X, and Windows. Let's start by configuring your linker and compiler for Linux, OS X, and Windows. We're going to talk about the linker.args, CPP compiler args, and toolchain variables. We won't go over all the options for the systems, but some basic ones to get you started. In Linux, usually the options are as follows. Let me go ahead and pull up an example build.gradle file to show what I mean. We're going to go ahead and show an example that comes with Gradle in the native binaries directory under a CPP folder. Let's go ahead and edit the build.gradle file. All right. Notice here we've got two big closures, and inside of this one we've got a lot of options. We've got CPP compiler.define. We can define variables here, so we can call them whatever you want. This one's called ndebug. Call it anything else you want. Do it multiple times if you'd like. We're also setting CPP compiler arguments. So in this case, if it's GCC, it sets these compiler arguments. The toolchain variable will tell you what you're running in. In this case, also, it can check to see if you're running Visual C++, and it will set different parameters to make Visual C++ compile correctly. If you want to do multiple values, you just comma delimit them, put them in double quotes, and you're good. You can do the same thing for linker arguments as well. That's a way of using separate parameters that are normally separated by space when you're working on the command line. Here we've got binaries.all. That means for every single type of binary, whether it's shared, static, or executable, it's going to go ahead and run this block of code on each of them. If you want to do specific compiler commands or linker commands for a certain type of artifact, go ahead and use the binaries with type. And then inside of the closure here, for the parameters, you can specify shared library binary, static library binary, or executable binary. And in that case, if it's a certain type, you can set compiler arguments here by using, again, your toolchain variable. You can tell if you're in GCC, Visual C++, etc., and set specific compiler defines, variables, or linker or compiler arguments.
So there are two types of dependencies when we're talking about building C++ projects. One is the project dependency, which Ryan will talk about in just a moment. And the other is an external dependency or pre-built library dependency. Now, this support's changed quite a bit in Gradle 1.11. And therefore, I'm pointing you here to the release notes so that you can get some more information about these pre-built library dependencies. What we can see happens is basically we set within repositories closures, lib closures telling it that we've got some pre-built libraries, and then we can specify the dependencies that are in question. So we've got a third-party library in this particular case called Boost, and then we've got another dependency called util. Each of these gives us the ability to specify the information that is going to be necessary for doing the build. So common between these two are the source store for headers. Headers are going to be important for us to link against, and we can specify which one we want. Additionally, we can specify the actual shared object file if we need to, and we can see that down here we're using a with type directive, and if we're looking for a static file, we're pointing it to a .a file. If we're looking for a shared library, we're pointing it to a .so file. Now, if we were to go and look in the sample directory, there is under the native binaries directory a pre-built project, which pretty much does the same thing that we saw before, only a little bit more detail. It's delving down into looking at the platforms and determining how we're going to be finding our shared libraries or our static libraries, and if they need to be DLLs, .libs, if they need to be .sos or .as. It's all in here. It's a great example. And with that, I'm going to turn this over to Ryan to talk to us about project dependencies a little bit.
Project dependencies. Just to follow up on what Lee said about using external dependencies for projects, we can also depend on projects within themselves, or project dependencies. So let me show you an example of how to do this. There's really two places we need to modify, and I'll show you each one of those, to use project dependencies for your C++ build. So if we could go in the native binaries samples directory included with the Gradle distribution, let's go into the multi-project directory. And then here we've got an exe and a lib subproject in there. So let's go ahead and look at the settings.gradle first. You'll need this to have any reference to the project. So inside of our settings.gradle, we've got an include command, and we're including the exe project and the lib project. Both of these are sub-projects from within this project here, as you can see in the directory. So let's go ahead and look at the build.gradle file and see how it uses that. So here we've got a reference to the, and a sort of declaration of the lib project itself. There is no build.gradle in the lib directory. We could have also done it that way as well. In this case, we've got the definition of the lib. It's using a C++ plugin, and it just has a simple library called main. Nothing special. Here we've got an exe project, another subproject, and it also uses a C++ plugin, creates a main executable, but then also in the sources, we've defined a dependency called lib, and this is how we use it, project : and then in single quotes, the name of the project, always referenced by a colon first, so we put :lib, and then comma, and then library : main. That means we're using the main library of the lib project. So this is all you need to do to have a dependency on one or the other. So now when we run our exe main, we've got our definition that it depends on our lib project, and we're good to go.
So we've looked at a lot so far in terms of building native artifacts. How do we publish them? Well, publishing could be as simple as applying the CPP lib plugin and then coming to a section to add and upload archives closure and specify a repository. It could be that easy if you're not using later versions of Gradle, such as Gradle 1.11 and higher. This support was ripped out of Gradle 1.10 and Gradle 1.10 because the support was not quite cohesive, and there were a lot of issues with it. So since the support right now is still in an incubation type of phase and it's still developing, this has to be done via plugin. And Ryan has found a plugin called the Gradle Native Artifacts plugin. It's on GitHub. You can see the URL here. And it's got all the documentation that is necessary in terms of how to bring this into your project so that you can publish your native artifacts. However, given this, Ryan and I didn't feel that this documentation was adequate enough. So we looked and we found a project called OpenCache. It's on GitHub as well. And it's an open source project that utilizes the Gradle Native Artifacts plugin to publish its native artifacts. And again, this is on GitHub. Here's the URL, and it uses the Gradle Native Artifacts plugin. We did download this plugin, and if I run Gradle tasks, we're well familiar with this command at this point. It's going to give us a list of all the tasks within the Gradle project that we can run. We'll see that there's a publish task. So let's go ahead and run that. Gradle publish. It's going to build our artifacts. It's going to do any packaging that's necessary. It's going to take those and put those into a repository. In this particular case, it's an Ivy repository. So let's come up and take a look at this repository. We can see that the first thing that we've got is a directory by group ID, then a directory by artifact ID, then a directory by version, and within that directory, we have the published artifacts. You can see that we have the artifact here. We've got our ivy.xml file. We've got our checksums. That is unfortunately due to the instability with publishing native artifacts in Gradle. At this point in time, the best information that we can offer you, but it is here. And the plugins are there, plus we've found a really good example for you.
New with Gradle 1.9 is support for variants, platforms, and flavors. You can build a debug versus a release version, 32-bit versus 64-bit, or a completely different platform than what you are building on. Let's look at a new closure called build types. You typically might pick release or debug. However, you can build any type you want here, and there's no real restrictions as long as the property is not already in use. Once those are defined here, you can use them in binaries all closure and reference them in code like an if statement. Let's look at an example. We're going to use the variants project here. It's under native binaries included with your Gradle distribution. There's a perfectly good example here. And here we've got build types, debug, release. And inside of the binaries all closure you see here, we can do checking against the tool chain and the build type. So in this case, if it's GCC and the build type's debugged, add the -G flag for the compiler arguments. And if it's Visual C++ and is debugged, we add even more arguments and even a linker flag here. Now let's look at a new feature, platforms. If you don't include this, it will default to a single platform called current. You can list them in the build file like so. Here we've got model and platforms. So here we've got x86, x64, and Itanium. We've defined 3 different architectures. But when we want to use them, we use them in the executables block here, and we've got our main closure, and here we specified target platforms. In this case, we're saying we only want x86 and x64, and only those, and we're going to exclude Itanium for now. It's useful if you're building a platform you're not deploying to, such as embedded development. So another platform might be ARM or ARM 6, 5, 7, 4, whatever. There is a limitation here, however. It only supports the operating system and architecture here. Future versions might include more options, like compiler versions. And now let's touch on flavors. That's new in 1.11. These are like language for a build. You can define them like so under model, closure, and we can define our own flavors here. And you can make up any flavors you want. In this case, we've picked English and German. We use them similar to the platforms in our executable. So here we're saying target flavors are English and German, so we'll build to those 2 flavors. And we can also, in our binaries all, reference a check against them. Say if flavor equals flavors German, print hello world in German. That's it for flavors and variants for now. Stay tuned for our next session with Lee building JavaScript projects with Gradle.
Welcome to the Gradle JavaScript integration section. In this section, we'll talk about the Gradle JavaScript plugin. There have been a few plugins that have come and gone, but all other ones are now about 2 years old and most likely don't work with the current Gradle versions. These include the CoffeeScript plugin, JSLib plugin, and Jasmine plugin. The most current source for this plugin is written by Eric Wendelin, and it can be found at GitHub. So if you go to GitHub, here's the URL directly to the project. You can just as easily find it by searching GitHub for Gradle-JS-plugin. Another useful plugin written by the same author is the CSS plugin. Again, located at GitHub, and here's the URL, and it is just as easily accessible by searching Gradle-CSS-plugin. So in this section, we're going to cover the Gradle.js plugin, as I mentioned. We're going to talk about how to specify your sources, combining sources. We'll talk about JS hint, JS docs, prop2js, require.js, all the several other really helpful plugins. And we're also going to talk about the CSS plugin that was also mentioned just a few seconds ago. Let's dive in and get started using the plugin to use Gradle to build your JavaScript project.
Thanks, Lee, for that intro. Let's go ahead and jump right into this. The first thing we'll have to do is tell Gradle to use the Gradle.js plugin. Let's go ahead and look at our example on how you do that. So we put together an example script based off of the default example. And here we've got a build script closure. This is often used to define dependencies for plugins. And in this case, we've had to define a Maven repository. As of right now, version 1.12.1 is not locatable in the Maven Central for some reason. So if you use the Spring Source milestone repo, it seems to be there. So all you need to make this work, add your Maven closure, add your URL closure to this magic URL here, and your dependency for this version of the Gradle.js plugin is going to go ahead and work. The next thing to note here is the apply plugin. We're going to use the name JS. That will define the plugin there. And next step, we want to look at the JavaScript.source closure. So you can define multiple environments here, kind of like how Gradle does this. We can, here we've defined a dev and a prod. So inside there we declare JS, so the plugin itself is going to look for this closure here. And in the case of dev, we're going to make sure we include all JavaScript and exclude any minified things to ease in debugging. And then here for production, when we want to do our production JavaScript release, we're going to go ahead and include the source, but only the minified source. And that way, things are more easily packaged and more streamlined for distribution. One thing to keep in mind is this closure here does seem to be a little flaky between versions. So before you get too far into using this plugin, just verify this include, exclude, and source directories features working properly. Because if it's not, you may need to back your version of Gradle back down to an older version, such as 1.10. In a case we've experienced here before. However, this new version of the plugin, this 1.12.1, things seem to be working a little bit better in this area.
Okay, so sometimes you might have multiple JavaScript files and you might need to combine them into a single file, perhaps for easier minification, better packaging, you name it, whatever your reason is, you may have to do this. Gradle JS plugin has that power. Let's take a look at how we would do that. If I go over to my build.gradle file and take a look at it. Now if I take a look at my build.gradle file, I actually can. Now, you'll notice down here the closure is combine.js. Real simple. Specify your source, which will be the directory that has your files in it. Specify the target file that you want. Right now, I'm just going to be taking all the JavaScript files, and then I am going to be combining them all into a single JavaScript file called all.js in my builder. If I come back out and look at running it, Gradle combine.js. We'll go ahead and take a second and let this run. It'll be really, really fast. Notice that if I do go into my source.js file, I've got two JavaScript files in here. One's 50 bytes, the other 45 bytes. So we're looking for something around 95 bytes. If I go back to the build directory and look, I should see all.js. And it is 96 bytes. So we're right there. We're good. That is how to combine all of your multiple JavaScript files into a single file.
JS Hint. To help with the issue of raising quality in your JavaScript code, Gradle JS offers integration with the JS Hint task. JS Hint will inspect your JavaScript code and find potential problems with your code. Let's go ahead and look at an example here. Okay, instead of our build file here, we've gone ahead and added a JS Hint task here. All we have to do is specify the source tree for it to look at and a destination file. So we're going to go ahead and write into our build directory a JS Hint.out file on some source. So let's go ahead and look at some source that might have some problems and run JS Hint on it. So we've got two files here. We've got a util.js, and that looks good. Nothing wrong with that one. And then we've got another one here. We've got an unused variable and an alert. Oh, we're missing semicolons, I see. Let's go ahead and see if our JS Hint will find this. So all we need to do to run it is run our Gradle task JS Hint. All right, we've go ahead and run JS Hint. Let's go ahead and look in our build directory and see what we've got here. Let's go look at JS Hint.out. That's where we told it in our build script to output the problems. Oh, look at this. Missing semicolon here. Oh, we don't like this file. It tells us exactly what line number it's on and what the problem is. It'll also find other issues such as undeclared things that aren't used. In this case, it didn't really find the variable, but it's a good thing to run for hygienics on your code. Good thing to run in your CI server, and we'll cover that in a later chapter where you can have this run every time someone checks something in and look for cruft in your code, which is really handy.
API documentation as part of your build process. You can integrate JS Doc 3 support into your project with the plugin. We must configure this in the JS Doc task, so let's go ahead and take a quick look at that in the build file. And the closure is going to be real easy as we set up a task called JSDoc. And we've got a type of JSDoc task. We're going to set the source of where we have our files, and then we're going to set a destination directory. If you want to use any of the specified specific JSDoc parameters, you can put them in the options.options parameter map. Now, those can be found in the web page for the plugin, which I have right here, and you can see the different options that are listed here. And the URL to get here is just an anchor tag off of the Gradle.js plugin URL that we shared previously. So going back, let's go ahead and run this and see what we've got. First of all, I do want to point out that in my JavaScript directory, I've got my utility. I've got some markup in here for the JSDoc, and we've got a very, very simple thing. Our purpose is to talk about Gradle's usage of JSDoc specifically. So we only pulled in this one example. Now I'm going to run the JSDoc task, at which point it will look through all the source files and run the JSDoc task against it. Now, if I look in my build directory, JSDocs directory, I can see that we've generated an HTML. We've got some styles out there. Let's go and take a look at what was generated to make sure that we actually have some output. And here we go. There is the generated global.html file that it will have all of the JSDoc 3 documentation in here generated from the annotations in our source code.
Props to JS. The JavaScript plugin also supports a library called props to JS. And what this does is basically has a simple task of converting Java properties files into JSON or JavaScript property files. Now, this is kind of handy when you're deploying a project and you're using properties with Java code and you need to mingle or translate that over to JavaScript code that it can use without having to have duplicate properties files throughout your code base. So let's just go ahead and show you an example of using that. Let's look at our build.gradle file here. So what we've got here is a pretty simple function here. It's just the task called props to JS. You just add that with a closure. We specify source, and we specify where we're just going to look at for source files, and we specify a destination file. So it can actually combine multiple properties files into one. So in this case, we're going to just grab everything out of our source resource directory and then put that into our build directory under props.js. So what I've done is created a basic properties file, and we can go ahead and run that, and it'll turn it into a JS file. There's also a props.function name here. So if you're converting this into JSON, P, or JavaScript, you can give it a function name to wrap it in. So I've just made one up here called magic. So let's go ahead and run that. All right, so we've got success here. So let me go ahead and show you also the source of where this came from, give you a little bit of reference. So I went ahead and made a test.properties file. It's just got some basic properties here. Test true, Gradle's awesome, JavaScript's hot. So now we go back to our build directory where it created this. And now we've got a props.js file. And now we've got an actual nice JavaScript file. We can reference with the variable magic, and it's got these values here. JavaScript's hot, Gradle's awesome, and test is true. You notice the order isn't exactly preserved. In most cases for a properties bundle, that's not really important as long as you can get the values like a hash map. Require.js is a JavaScript file loader and module loader. Require.js support for the plugin is provided through the art.js framework used for Require.js Optimizer. The Require.js Optimizer for Node and Rhino is located in GitHub, and I'll go ahead and show you that here in a second. Then we can jump into depth in the Require.js library and read up on their docs as well at requirejs.org. Go ahead and look at that website. So here, if we go to the GitHub, look for jrburk.r.js here, as we show, and if we go to requirejs.org, we get the full docs of the possibilities we can do to this. Basically, it'll just help us load and manage JavaScript files for dependencies. So let me show you an example of using it with the JavaScript plugin here in Gradle. So I'm going to go ahead and look at my build.gradle file. And all we have to do is add a closure called require.js, the capital J there, specify the source of where the JavaScript source files are, and then the destination. So what this is going to go ahead and do is take several JS files and bundle them together with the require.js library as an out.js, and then wrap that in some calls. We can specify our options here. These are a little bit tricky. One thing that's not all that clear in the docs is you need to specify a base URL. If you don't specify this attribute here, it'll stick with the word undefined when it actually runs the library, which won't work. So you can put dot in there, and then you can specify name and location. It looks like they've kind of merged the name and the main properties together. So for name, you need to give it the path to the JavaScript file as well. And location is, I think, a little bit of syntactic sugar at this point, since they've sort of, in the plugin itself of the JavaScript, combined those there. Let's go ahead and run this and see what happens. We just run our require.js task. All right, that worked successfully. So let's go ahead and look in the build directory and see what this output here. We've created it for us an out.js file. And what it does is it added a function called misUtility. I didn't define anything else, so it just added that under this bucket called misUtility. And again, we've got our util.js here wrapped inside of there with a definition to include and call this JS file for you. So a nice tidy way to keep your includes nice with your JavaScript libraries.
So if you use the JavaScript plugin for a web project, then most likely you're also going to want to use the CSS plugin related to it. It's written by the same author, mostly to complement the JavaScript plugin. The plugin gives you similar functionality to the tasks in the JavaScript plugin, such as combine, minify, and compress. And it also supports a less in CSS lint. Now, we're not going to cover it in depth here, but if you look over here on GitHub, you'll see that I've got a URL for the CSS plugin on GitHub. And right off the top, there is going to be some nice quick starts for how we set the dependencies and apply the plugins. We'll see that there's examples for combining CSS, minifying CSS, zipping it. There's less support for CS lint. And we've got a little bit more documentation down here. Go through this quick start, and I promise you'll get some benefit taming your CSS resources just a little bit more, just like using the JavaScript plugin. In this section, we took a good look at the Gradle JS plugin. This plugin gives us the powerful support to be able to leverage JavaScript code in our applications. The support really leverages upon the strengths of Gradle to pull files in from many diverse locations and can afford us the opportunity to build differently based upon the needs we have for our different environments, like dev, QA, and production. We also lightly touched on the functionality in the Gradle CSS plugin. So to recap, we've talked about the Gradle JS plugin installation, how to specify your sources, combining your sources. We talked about JS hint and JS doc. We also looked at props to JS, require.js, and briefly covered the CSS plugin. Up next, let's talk about Scala support in Section 8.
Section 8, Scala support. Here, Scala users will get familiar with the Scala plugin support. This will teach available tasks, layout, setup, and dependencies. Here's a list of topics that we're going to cover in this section. Usage and tasks, project layout, compiler setup, compilation, and execution, dependencies, and fast compiler support.
Scala support is provided via a plugin that extends the Java plugin. Let's take a look at it. If I go into our current Gradle installation directory in the samples, and particularly the Scala examples, we'll see a project called Mixed Java in Scala. And if I take a look at the build.gradle file, what I see is very easy to identify the Scala plugin. It's the only one there. Again, this extends the Java plugin. And what can we do with this plugin? Because there's not a lot of task definition in this example. And we can go and do something as simple as compile Scala. And this task is going to do exactly what you thought it would do. It's going to compile our Scala. But notice that it also compiles our Java application to Java files. This is because of the dependency that compile Scala has on compile Java. And because of this dependency, we can also mix and match all of our Java files and our Scala files together. We can put them in the same directory, it doesn't matter. And in fact, that's what's happened here. If I do a find from
my current directory, all my Scala files, then I see that they're all within a Scala directory. If I look at my Java files, they're all over the place. Well, not all over the place. They're split between a Java and a Scala directory. Because of this cross-compilation, you can mix your Java and your Scala code together. So that allows you to be able to have your Java classes extend Scala classes and vice versa. Other tasks that we can run, well, we can run Gradle compile test Scala. And this will do exactly what you think it will do. It's going to compile the classes in the test directory. And we've got Gradle Scala doc. This is going to take take all of our Scala classes and run the doc task against them. The docs, by the way, will be created in the build docs Scala doc directory, and we can see that it's put all the files out there, the index.html, all the content appropriate to it. Now, what if we were to go and see if there are any other Scala-related tasks out there? Obviously, we probably should have run Gradle tasks before. And I see that we've got some tasks out here for Scala console and Scala test console, brief description of what they do. But I do not see compile Scala. I see Scala doc. Compile Scala is not here. My test compile is not here. Where is it? Well, as it happens, Gradle test is not going to show the Scala doc because it's not an actual task. It's what we call a hidden task or task rule. And if we want to see them, then we can do a Gradle task -- all. Now, this is going to go and look for all the tasks that we have in there, obviously. And if I scroll up, there we go. Compile Scala, compile test Scala. These are classes or tasks that extend the parent task. They're hidden, they're task rules. And they're there, we can execute them, but they don't necessarily show up with just our basic stock list of tasks. Now, this basically demonstrates the cross-compiler ability. We'll jump into that later on in the compiler section.
Okay, let's talk about project layout. When we use a Scala plugin, our project should have the following structure. Let's go ahead and look at the previous example Lee talked about under mixed Java and Scala. Now, if we look at the directory structure here, what we should have is a source directory, a test, a Scala underneath that. We could have a source test Java if we wanted to. Then we have a source main Scala and a source main Java. Under that, we've also got our Gradle artifacts there and our build directory. Note that the Java directories may only contain Java sources. Scala directories may contain both Scala and Java sources like Lee mentioned. If you don't have any Java sources, don't sweat it. These directories don't need to exist or need to be populated. The Scala plugin will compile anything that it finds. Remember how we could change the location of files with a Java plugin? Well, we can do the same thing with a Scala plugin as well. It's just as simple as adding the following code using source sets. So let's take a look at that. We go into an example here. It also ships with Gradle called customized layout. So if we look in here, we've got source sets, and we can define a main directory, a test directory, and in there we could create Scala directories and then specify the actual physical path of where these are located. So you can make that, if you have a legacy structure, you can make it point to wherever you want. And this will help the Scala plugin find your source code.
Compiler setup and compilation. The Scala plugin can use a couple of different compiler setups, and built-in compiler is the Zinc compiler. This uses the Gradle compiler daemon by default. There is another option that Ryan's going to talk about in a few minutes under fast compiler support, so let's focus on what we can do with the Zinc-based compiler here. Now, if you don't want to use the Zinc-based compiler, I have some good news for you. You don't have to. You can always use the Ant-based compiling by adding in just a single line or modifying a single line. Let's take a look at that. bi build.gradle. The line in question, Scala compile options.useAnt equals, and it's very straightforward. False if you don't want to use Ant, true if you do. Now, Why would you want to use the AMP-based compiler? Well, the reason why is because this will cause Gradle to fork a new process each time you want it to run. So maybe you're writing some tests and you need to reset things in between, resetting your JVM context. That's a great way to do it. I'm going to suggest that you leave the defaults alone for using the Zinc compiler. It's probably going to handle most of your needs most of the time, but you can come down here and change the configuration. Let's run this and see what things look like. So Gradle's my command, obviously. I've been messing around with this earlier, so I'm going to do a clean. And what we want to do is compile some Scala. Now, I've got to be honest here. I kind of sabotaged this a little bit, so I'm expecting a Java heap space error. And it should come up just momentarily. Yeah, there it is. Java heap space. Why did that happen? Well, because I did not leave well enough alone with those defaults. I came down and I changed my memory maximum size from the default of 1 gig to 16. It's quite a difference, huh? So now if I rerun this, same command, Gradle, clean, compile Scala, it should work just fine. And it does. All right. So again, it's just a quick demonstration of how you can change the compiler configuration. But my suggestion to you is leave it alone. You're probably going to be okay. Now, let's talk about one other thing, and that's incremental compiling. Incremental compiling is where you only want to compile the things that have changed since your last compile. And the way that we would do that is to come back and take a look at that same Scala compile options.useAnt. Set it to false. This forces it to use the Zinc-based compiler, and it's that compiler that has the incremental compile options in it. So use Ant for forking new processes, resetting things. Use Zinc because it's packaged and probably just a good idea and a lot easier. But it also provides that very, very valuable incremental compile support. Okay, so I've got Ryan coming up in just a few moments to talk to you about dependencies and fast compile support. But before I turn it over to him, I want to bring up some documentation. We've got at Gradle.org's in the user guide documentation for the Scala plugin. Easy to find, full of lots of great information for you. So you can either search for it or you can come directly to the URL that I've got highlighted right here. Thank you very much. And without further ado, Ryan with dependencies and fast compile support.
Dependencies. Declaring dependencies for Scala isn't much different than doing it for Java. The only real difference is making sure the Scala library is set in your dependencies. Let's look at the following code snippet to make sure that's set up just so. We'll look at one of the examples Lee was just using here. So we see in here we've got our Maven Central and we've got our dependencies for the Scala plugin. It's got the org Scala lang plugin here. When you go ahead and run your build, it's gonna for the first time it's gonna go ahead and download the Scala support and plugin, and then you're good to go. Also, we can restrict the usage of a given lifecycle, just like we can with the Java plugin. So, example here, we've got a dependency for test compile. So we only want the JUnit library to be dependency to be valid when we're doing test compilation, not when we're running our distribution. So we just use the test compile label here, and we can build our JUnit in only when we're running the test, but not when we're doing anything else. And that's about it for the dependency management support. Everything else is built off of the Java plugin. We can also refer to the docs here for dependency management. If you need any more information, you can get it here. And that's it. Fast compiler support. The Scala plugin contains support for FSC, or the Fast Scala Compiler. FSC runs in a separate daemon process. By doing so, it can speed up compilation quite a bit. You can turn on FSC support in Scala plugin with the following lines in your build.gradle. Let's go ahead and look at an example here. This ships with the Gradle distribution under the Scala samples directory, where there's a directory called FSC. And let's look at that build.gradle file. All we have to do is add a compile Scala closure here. and we add this Scala compile options. Use compile daemon equals true, and then go ahead and set your daemon server properties there. And that's all you need to do to enable fast compiler support. This is a little bit less mature than using the Zinc compiler, but if you have a really, really big build and it's not running fast enough for you, you can use this as another option to enhance your performance. If you need more information on the fast compiler support, refer to the Gradle documentation here under Fast Scala Compiler. And there you go. That's all you need to do. All right, that concludes the Scala section. Thanks for listening to Section 8. In this round, we've covered usage and tasks, project layouts, compiler setup, compilation, and the Zinc compiler, dependencies, and the fast compile support. Next up, Lee's going to talk about continuous integration servers. Very exciting stuff.
Section 9, Continuous Integration. What is continuous integration? Well, according to our friends over at Wikipedia, continuous integration is the practice in software engineering of merging all developer working copies with a shared mainline several times a day. You can read a little bit more about it on Wikipedia, real easy to find, but I gave you the URL down here just for your reference. What does that mean, though, taking developer working copies and merging them with a mainline several times a day? Well, if you were a developer in a shop where you were coding all by yourself, like our friend Bob here is, then Bob's work would go from his computer, or Bob, to source control when he checked it in. This might be Subversion or Git or CVS or Perforce. And then at some point in time, there's going to be a build, and this build could be an automated thing using Maven, or maybe it's a manual type of build process. If you're taking this course, then you're probably going to want to use Gradle for that. But that's beside the point. Now, this build may turn out errors that would have to go back to Bob to fix, and then those errors those fixes get checked into source control and go through the build process again. Then you may potentially go to a deploy of that build to a QA system. It may go to production, whatever your particular environment says. And if you're testing, you may find errors that, again, have to go all the way back to Bob to check back into source control and put into build. And you just repeat until you've got perfect code. But that's in a very, very simple environment where Bob is the only developer out there. What if we have multiple developers and Bob has to share the glories that he has with Steve, Joe, and Lisa? In this particular case, all these developers are going to be working on their projects and their assignments simultaneously. Their fixes get checked into source control, and then pulling from source control is your build process. Hopefully it's Gradle. And then there may be an error that comes out of here. Again, it has to flow back to the developer. The developer fixes it, puts it into source control. We're going through the build again. And then we would get down to that same deploy test area, and that may turn out a bug. That's got to go back to a developer and come through again. What's happening here is we're trying to take work from each individual developer and bring it all together and make sure it works. This process is called integration. Now, if we had something that was doing this again and again and again for us, that would be continuous integration. Back in the day, continuous integration was really just a manual process, and somebody on the team would get sidled with it. It might be a build master, or it could be an assigned developer, or maybe it's a shared activity that gets moved from person to person. Nowadays, continuous integration is something that we see more as an automated task. And there's lots of software out there that can help us do this. Some of the bigger ones are Jenkins, TeamCity, and Bamboo. We're going to be talking about Jenkins, TeamCity, and Bamboo as three of the largest and most popular continuous integration servers that Ryan and I have identified. And we'll talk about that in Section 9. So with that, let's go ahead and start talking about Jenkins first.
Jenkins. Jenkins is a CI server born from Hudson. Hudson was the original CI server that became the rising star of open source until Oracle acquired Sun. And after some new direction, the developers rebelled and forked Jenkins. There are people still maintaining Hudson today, but most likely the Gradle plugin will work, as Hudson users seem to regularly backport features to Jenkins, and Jenkins is now the leader, though, of the open source CI server. So if you're doing a fresh setup, go with Jenkins, unless you have some kind of legacy Hudson thing going on. If you don't have Jenkins installed, let's hop on over to their main website and show you how to download it and do the basics. Here's jenkinsci.org. We see there's two different ways you can install Jenkins. If you already have a Tomcat or a web container running for J2E, you can put the WAR file in and it'll automatically start and configure itself. Or you can run the native installation, which is easy. If you don't have any existing setup, it'll do all that stuff for you. Here we've done the Ubuntu Debian installation. And once that's completed, follow the instructions. And once that's going and it's started, I'll take you to the next step, which is installing the Gradle plugin. So here I've got my basic installation. Let's go ahead and install the Gradle plugin. We're going to go to Manage Jenkins, Manage Plugins, click on Available, and search for Gradle. We just need to check the box here. Make sure you check out Download and Install after restart. You'll get undefined and flaky behavior, so it's always best to restart Jenkins after you've installed the plugin. And just to be sure, in case you have big builds going on, it makes you check a box. It makes you restart Jenkins. So it will get a clean install of everything. So once this restarts and comes back up, we'll be ready to use the Gradle plugin. Okay, now that we've got our Jenkins Gradle plugin installed, we're ready to have some Gradle installations for Jenkins to use on our project. So to set that up, we're going to go to Manage Jenkins, Configure System, and go to Gradle installations. And here we can say Add Gradle, and we can add different kinds. We can say Install automatically from the Gradle website and pick our version. Or we can, on a build itself, say use the Gradle wrapper, or we can pick a locally installed version. For here, I'm going to use a locally installed version. Please note, if you are going to use the wrapper and you're going to distribute your application to others, you really should use the wrapper, and it's preferred by the Gradle community as the proper way to go. We've talked about this in the past, but if you're using the Gradle wrapper, someone can just download your project, and it will automatically download and install the right version of Gradle for you, as long as you run commands through the Gradle wrapper command. So I'm going to go ahead and save this here. Before we get too far, you should know a couple of shortcomings of the plugin that are being addressed by the Gradleware team. One is deployment of Jenkins jobs from Gradle, in other words, deploying code to somewhere, or building of Gradle plugins from within Jenkins. There's no real support either for building plugins specifically for Gradle and Jenkins that really help you out there. If you're not trying to do one of those two cases, let's continue. Otherwise, check the Gradle org website periodically to see if there's any new developments or updates on the workarounds or these shortcomings. Let's go ahead and dive in and create a sample Gradle project. We're going to go into Jenkins and go to New Item and say Freestyle Project. We'll just create a test. And we'll notice here we've also got some Artifactory integration. Make a mental note of these later when we get into Artifactory integration. Otherwise, let's continue. And I'm going to jump into one that I already have working with some source code in it. So I'm going to go here. I'm going to go into Configure. And we're going to go to, say, invoke build step, say invoke Gradle script. And I've already done that here. So I can go in here, pick the version installed, or use the Gradle wrapper. If you have physical access to the box, and all of your projects use the same version of Gradle, it is faster, at least initially, to use the locally installed copy of Gradle and save disk space instead of using the wrapper. So otherwise, just make sure it's installed. If you don't have the ability to set up Gradle on your CI server or auto-install it, well, you have to select Use Gradle Wrapper. You should only use this as a last resort in a lot of cases, because for each build you configure, it'll have to auto-download Gradle from the wrapper each time, which will make your builds take a lot longer. It is, however, the considered best practice by the Gradle team to use the wrapper, but Jenkins has really good support for not having to need it. You also see the ability to include switches, tasks, separated with space, the root build script, and the build file. See all that stuff here. The root build script is important because if wherever your build.gradle file is located, you need to specify that relative to where you checked out your source code for the job. And then tasks here, we've got war. We can specify with spaces and run multiple ones like clean war, compile, and whatnot. And we can also use our environment variables. And here's a good reference on the Jenkins wiki of all the different environment variables you can use when you're invoking your Gradle script that Gradle can then reference and put into your build, such as the build number and build ID, build URL, things like that. Since our sample project uses build.gradle, we don't need to fill in any special name here. You could put in build.gradle for better documentation's sake, but it's unnecessary unless you've chosen to choose a different name for your main Gradle build file. And we're going to use the war task to get started. And later we can add tasks like upload archives to publish them to repository manager. We're going to cover that in the section with the artifact managers like Artifactory and Nexus and things like that. So we can save a jar and publish it for usage later. When you run the build, you should see a successful build message. So I'm going to go ahead and save this. I'm going to go ahead and build now. And we can see that it's building and it should be successful. All right, and the end here. Now I've got a war file as my artifact, and that means we're good to go. We're all set up with Jenkins, and we're building our Gradle applications.
All right, let's talk about Team City, which is the JetBrains entry into the continuous integration world. So I've got Team City set up in a browser here. And what I'm going to do is I'm going to walk you through some of the changes that we've got within this project, rather than setting this up from a brand new project. And the reason for that simply comes down to the security that we've got over our source control system, our Git repository, and keys that have to be uploaded. And it's just going to be a little bit easier to show you the specifics of these projects this way. So if I go and I take a look at a project that I've got created in here called Gradle, TC Gradle Test, Team City Gradle Test, and look at the project settings. Now, obviously, when you create a new project, you're going to have to give it a name and a project ID. Make sure that you've got your VCS or your version control system root set up. This is incredibly important. Team City is going to want to know where to pull your source code from. So once you get your repository set up, it gives it that information. Now, if we look under the general configurations tab, we'll see that there is a build configuration. I am actually going to delete this so that we can walk through this process ourselves. And I'm going to create a brand new build configuration. And with this build configuration, I'm going to call it my Gradle build. And I'm going to create. Now, what this is going to do is prompt us for where are we getting our project from. So we're going to look at the previously defined route that we set up, and I'm going to choose that and tell it to attach. At this point, Team City is going to go out and scan the project and see what kind of build tools are out there and how we can customize this. So I'm going to tell it that I want it to use the Gradle installation, Gradle build that it found. It did find that there was a wrapper there. And to note, before I checked, when I checked this project in, I did run the Gradle wrapper task on it, and then I checked those wrapper files into the project. So now it's found it. I will tell it to use. We're almost set to go. I don't want it to run clean build for my build. I want it to run war. Now, there's a couple of things that can happen in here. Let's look at, I'm going to hide the advanced options. I'm going to show the advanced options because it'll highlight them a little bit better for us in orange. Now, couple of things I want to bring your attention to. Incremental building. If you turn this on, it's going to use the build dependence tasks to draw out what needs to be built and only build things that are changed. There's a working directory so that if you want to change if you've changed where you're checking this out to, you can do that. There are some Java JDK options that you can specify down here. And these will be things for setting up memory heap size changes and such. But for right now, the most important thing is just tell it which task to run. So we're going to save that. And then we're back here, and we'll notice that it's telling us that we're just going to run Gradle War. Now, if I go up, let's go back up to the general settings. The other thing that I will want to do is specify the artifact paths. When the project gets built, it's going to generate the war file in question, and then it will put it into the build libs directory. By default, Team City is unaware of that. So I'm going to tell it this is where you can find the artifacts. With that set, let's go ahead and run this build. So we're loading the current repository state. It's basically transferring down all of the changes from our source code repository. It runs the builds, and if we look in here, we can see that we'll get a list of changes that have happened. We can look at the build log. Specifically, I can expand Gradle out, and I can see that this is the same exact output that we had seen before from running our Gradle tasks from the command line. We ran the war task. We've got some dependencies on compile Java, compile Groovy. And we can look at the artifacts. And here it is. This is the war file that was built. The name, granted, looks a little bit funky. Team City is populating in the build number for this. But if we expand it out, we can see all of the contents of this war file and everything in here. My JSPs are in the right place. I've got a web inf directory, classes that have the compiled code that I'm looking for. And we've got our dependencies here in the lib directory. Again, this is exactly what we would find if we ran the Gradle war task from the command line, then expanded the war. So there's not a whole lot to Team City because it is really, really tightly integrated with Gradle and has some great support. All you have to do in a nutshell is set up your version control, your source code repository routes, and then tell it to scan the file, and also make the little note in there of where the artifacts are going to be. And then you're set to run. Everything else beyond that is pretty much going to be Team City specific configuration for when you want to set your builds to run upon check-in, polling, if it's going to be a scheduled time, or making some small tweaks to the Gradle settings. And again, I showed you some of the advanced options for changing the heap size and such.
Okay, let's talk about Bamboo. Bamboo is Atlassian's CI server. Atlassian is the maker of products like Jira and Confluence and Bitbucket. Bamboo comes in two major flavors. First, there's a hosted version, which you can use if you have Jira on demand. Also, there's a downloadable version you can run on your own hardware behind your own firewalls. Sadly, Gradle is not supported natively by Bamboo, but rather is supported via plugin. So you can either use Gradle Wrapper or use the Bamboo Artifactory plugin, which contains a runner for Gradle. We recommend this over the commercial Groovy plugin, as the Artifactory plugin has no cost. All right, let's cover the Bamboo Artifactory plugin. The Bamboo Artifactory plugin will require at least Gradle 0.9, Artifactory 2.25 or later. Let's go ahead and pull up the web page for the plugin. Here we've got the plugin, and we've got a list of all the versions for Bamboo here. So check which version of Bamboo you're running and download the right jar file for it. Once you have the right versions of all the applications and dependencies installed, using Gradle with the Artifactory plugin just requires that you have a valid build.gradle script. Also note, when you install the plugin, make sure you copy the jar file here into your webinf.lib folder for your Atlassian Bamboo if you're running it locally. Now let's take a look at how we specify the build.gradle file and run those builds with Bamboo. Okay, let's cover the Gradle wrapper real quick in Bamboo. First of all, in your project, you need to make sure you actually have the wrapper set up. You can type Gradle wrapper like this if you don't already have the wrapper set up. But if you already have it, like this example here, you can see we have a Gradle W and Gradle W.bat. That's the Gradle wrapper. So you can run all the Gradle commands like you would if you had it installed transparently through that. So you're going to go ahead and need that to in your project first to be able to use the wrapper support in Bamboo. So let's go ahead and do that. Now we've got a project with that, and let's go check it out in Bamboo. Okay, here we've got a test. We can go ahead and edit this project we've got here. We go into the stages. We've got a default job, and then we've got a Gradle stage here. It says create war file. So we're going to go ahead and look in this section here under our task for this configuration, and you can see here we've got the checkbox use Gradle wrapper. So it's going to always know to look for that Gradle W command depending on what platform you have, and maybe the batch file or the shell script. If you don't check that, you fall back to here where you install executables inside of Bamboo. We have 1.11 here, but we're going to go ahead and use the Gradle wrapper. That's all you need to do there. If it's somewhere not normal, you can specify a specific path where it's at. And all you have to do is click save, and you're using the wrapper. That's all there is to it.
So that's continuous integration with Gradle. We talked about what exactly continuous integration is, and we looked at three of the more popular CI servers: Jenkins, TeamCity, and Bamboo. We did not cover a couple of the older CI servers like Cruise Control and Anthill. These servers are no longer as popular, and the coverage for dynamic language support isn't that great. So if you're at the point where you're using Gradle, they're probably not going to be worth your time. You can now dive deeper into more complex Gradle configurations on your own, and when you're ready to publish those artifacts to a repository like Artifactory or Nexus, we have the next section on repository managers coming up very, very shortly. Welcome to Section 10, Repository Managers. We're going to learn which repository managers play nice with Gradle to save you headaches later on. What is a repository manager? Well, it's a service or an application that will provide management capabilities for the artifacts that you build from your Gradle projects. Think of them as a source control system for your WAR files, jar files, application executables. They provide dependency management, versioning, and distribution for these artifacts. In the Java world, two of the most popular ones are JFrog's Artifactory and Sonatype's Nexus. Bintray is a fast up-and-comer, so these are going to be the three repository managers that we will cover. Again, Artifactory, Bintray, and Nexus.
Artifactory. The company behind Artifactory, JFrog, also creates Bintray, which is a streamlined way to post binaries in a Maven-like repository. Bintray is sort of a combination of public aspect of GitHub with a distribution mechanism like a Maven server. Think of a public SaaS Artifactory server. For all this to make sense, let's dive into Artifactory first. This is one of the easier to install repository managers out there, and the free version does plenty out of the box for most people. Let's get started by including the dependencies in the plugin itself. Let's pull up the code. Alright, here we add the build script closure here, and we have our repositories defined. We point to the repo Artifactory org server, and another important item to include here is this dependencies block. This pulls in a org JFrog build info. This special class will make sure that the Artifactory plugin is available in Gradle itself. Once you have added that part, you just need to enable the plugin for your project. If it's a single module project, you can do it one way, and if it's a multi-module project, you can do it another. However, you can always use the all projects closure here, which works for multi-module projects, like this example, and it will work in either scenario. The other way is traditional at the top here, apply plugin, just put apply plugin and then Artifactory. So here I've defined it here, and I've set some global variables here. This is the group artifacts. It's going to always say com.zan, and the version is always going to say 1.0.0 unless we specify otherwise for all projects. Once you have your project ready to use with Artifactory plugin, there's a complete Groovy DSL for the plugin at your disposal. Before we get too far into all of the options available, please take a look at this link in the Artifactory website for all the configuration options for the plugin. Let's jump over there real fast. Here we've got their wiki page, and they've got all the documentation for the plugin, how to install it. If you're using the brand new, just released Gradle 2.0, it works a little bit differently. And if you're running before 1.8, it also works differently. So take a look at this page here. This is the link, and it will have everything about the DSL, all the options you can do, the configuration, and whatnot. Let's just go ahead and jump ahead with an example of a project that does use this plugin. So let's go back to that real quick. All right, first we're going to add a closure called Artifactory to our build.gradle file. And here you can see we override the artifact server URL to your own. So here we've set up our own server for Zan, and this is our free version that we've installed of Artifactory, nothing special here, vanilla installation. And we've got the publish block and the resolve block. So looking at the example above, you'll need to decide if your project will use Ivy to resolve your artifacts in your system or Maven. If you don't need Ivy, you can remove all of the closures labeled Ivy and set Maven value to true. Recall for artifact resolution, you can go back to the chapter we covered under dependency management, so we don't need to cover how to resolve artifacts in your project with this. Most of the options here are for publishing your artifacts. Once this section is configured, all of the options around Maven or Ivy resolution apply to the previous chapters. One common issue people have is how to publish an artifact to a repository that requires login credentials. Take a note of the examples here of our server. We've put in a username and password here and the configurations for doing so. People often forget to declare this and often post, "Why can't I publish to Artifactory?" when by default, Artifactory require credentials to do so. If you're running Artifactory inside a secure network and is not for public consumption, people often set it up to allow for anonymous publication. If this is the case, you can comment out all of the parts of the username and password combinations, and it will use the built-in anonymous publication option. The Artifactory plugin is a special closure you define for a publication that is separate from resolution. Here we've got the publish closure here. Behind the scenes, the plugin declares the section for you. Only declare this closure if you want to override or change the behavior of it with your build, in cases such as a custom POM file name or Ivy descriptor. If you don't, it will follow the Maven Ivy naming pattern for resolution and POM generation. One example of doing this is for different POM or Ivy configs per environment, a la dev, QA, or prod, and operating system level behavior changes for properties is noted in the example in the wiki link on their JFrog site. For setting customer properties of the plugin, refer to the documentation the URL noted earlier that we just looked at a little while ago. The last item I'd like to call out here is setting the build configuration name and build number. Now we've got that set here. If you're using Jenkins, you want to put in the build number, the system environment variable, or you can declare it here. Here's an example of declaring it inline. We can set the build name and build number. If it were a system property set from Jenkins, for example, you could put that in here and just use Java syntax for getting system properties. Well, that about wraps up what you need to know for Artifactory. Next, we'll cover bin tray plugin for publication, which is really a much more simplified version of what we've done here, just done in a way for open source libraries for public consumption.
So the bin tray is more of a social version of Artifactory, a la GitHub. Let's dive right in with how to configure the plugin. It starts off similar to the Artifactory one, but it's a little bit more simplified. So we, like Artifactory, we start off by setting our repositories on our dependencies. And then we'll have to come down and, like any other plugin that we've done, we have to apply the plugin. The rest of this project is basically a small struts application. I'm just building a jar file, actually, putting in the plugins that I'll need to do that, compile Java, etc. We do have a bin tray closure, and there's a couple of things in here I want to call out for you. It's mostly ready to go, just some default information that you can pull over from plugin site that I'll show you in a little bit. But I do want to call out some specific pieces of information. we do have a username and key. This could be username and password. I'm taking advantage of a feature right now that allows me to pull these values from a properties file, from another file where I don't have to have my username and password in my build file set up to be in clear text. I can make it a little bit more dynamic. I can make the maintenance of this a little bit easier. I'll show you how to do that in just a few minutes. Now, I've also got this dry run variable here. And what dry run will do is if I set it to true, it will run through the whole process, but it won't actually send it to BinTray. It'll just let me know if I've got any problems, and I can run through my whole debugging and generation of my build project without having unnecessary builds deployed to BinTray and such. The next one is publish. When you publish to BinTray, you'll need to go to the site and press a button that says publish my artifact. I've got a couple of unpublished things here. If you set this to true, then you won't have to do that. It'll automatically be done for you. Now, I'm going to leave it to false so that I can draw your attention to it when we get to the BinTray and I show you the site. Now, we specify the repository name within my package. I can specify a user org, but it's optional, so I'm leaving it commented out. We can give it a name of the project. There are configurations and publications that we can do. Configurations are going to be just that, configuration files. Publications are going to be things needed for Maven, i.e., that is, POM files. And then just some more metadata that we can add to our project. Now, the rest of this is fairly simple. We've got things that we've seen before, dependencies and repositories. I do want to bring your attention down here to the all project section. I've currently run this a couple of times, and I need to change the version because I already have a version 1.0.4 in my BinTray repository. So we can also go in and have this auto-generated, throw in some Groovy code and such, beauty of Groovy. For right now, I'm just going to leave this static. That's what the build.gradle file looks like. Now, let's go and take a look at the command line. All right. The directory is fairly standard, things that we've seen before. Notice that there are a couple of different files in here, Artifactory Gradle, BinTray Gradle, Nexus Gradle. In our sample code, we wanted to specify all of these to be different, but how do we run this? Because we do have a build.gradle file. Well, if I run Gradle with a -b parameter, it allows me to specify any file I want to run instead of build.gradle. So I'm going to run bintray.gradle. And let's just make sure that everything's kosher. Tasks is a great way to do it. Analyze that project, bring up a list of tasks, and make sure that we've got the targets in there that we need. You'll notice that for publishing tasks, we have BinTray upload. That's great. And everything else we see here is pretty much on par with the plugins that we've specified within our bintray.gradle file. So let's now talk about those that username and parameter, where it comes from. It's coming from my gradle.properties file. You can see I've got BinTray user prop, which matched the value for my username. BinTray API key prop, which matched the value for my API value within my build.gradle file. And I'm specifying my username. This is my account name in BinTray. And then I've got this long API key. This is a great thing for keeping my password safe, and we extract this value from the BinTray site. I'll show you how to do that in just a minute. Well, let's make sure it works. So bintray.gradle, and I'm going to run that BinTray, and I'm going to run that BinTray upload task. And this is going to do exactly what we would expect it to do. It's going to build our file, it's going to package it, it's going to send that sucker right up to BinTray. And it's successful. So now we can head over to BinTray. And here we are. So I'm going to refresh my project page. And you'll see it says I've got 2 unpublished items for the repo. This is that link that I was telling you about. If in our build.gradle file we had set publish, auto-publish equals true, then we wouldn't have to come in and actually click that button. But it's here now. There's my version 1.5. and we can look through the project. So if I come down to my version 1.05 and look at files, well, here are the POMs that I put up, and the jar file. It's my section 10 example, version 1.05 jar and POM, and it was done moments ago, real time. So that's how Bintray works, but I'm not going to finish there. I'm going to show you how to get that API key because it's a really great feature. So if I come up to my profile and then select edit, we have a list of links here on the left in the navigation. I'm going to select API key, and Bintray will generate it for you. So copy this, put that into your Gradle.properties file, and you should be ready to go and conquer the world with Bintray and Gradle.
Gradle integration with Nexus is quite simple, as Gradle already supports Maven integration. This leaves you with two good options, the Gradle Nexus plugin and the regular Maven support. Now we're going to look at the Gradle Nexus plugin because we've already talked about the Maven support, and that's no different. So let's focus on the Nexus-specific features. It depends on the Maven plugin and adds additional properties to control POM creation and authentication. To get started, you just add the following to your project. Let's go take a look. All we need to do is say apply plugin Nexus, and this apply plugin Maven is actually redundant because it extends the Maven plugin. That's just there to be for clarity's sake. And you also need to add the following dependencies closure. So we'll add this dependencies block here. It's got org Gradle API plugins, Nexus plugin, and then we're ready to go. A nice feature also is it adds signing, so you can still use the upload archive in Maven tasks. And we can configure that later. We'll get to that in a second. The plugin also adds a Nexus closure, and you can have more straightforward ability to set your Nexus server properties. So let's go take a look at that. Here's where we can set whether we want to sign or not, and our Nexus server properties. You can put some authentication details in there if you'd like, and all of that will be used by the plugin. And now let's take a look at our example project and run it. So we've got a basic plugin. It creates a struts app. We're going to go ahead and publish that to our Maven Nexus repository. Let's go ahead and run that real quick. And also the Nexus plugin creates a couple of extra tasks here, so we can run Gradle tasks. And we've got a couple of things such as test classes and test jar. Really minor additions, but worth noting here. And to upload our project here, we can just run Gradle upload archives. And we specify username and password if we didn't specify that in our build.gradle file. And I'll go ahead and upload your file there. And we can see that it's uploaded. Let's go ahead and look at our Nexus server and verify that it's working properly. So all we need to do is go into our Sonatype Nexus. I've created a test repository. And we can point to our repository path. We can see everything's been published here. We've got our section 10 talk, our example. We've got POM files, XML files, and we've got all of our jar files that we've uploaded here. So you can see I've done quite a few test runs. Everything will be there. This is a snapshot in this case. If you're not using snapshots, just change the version number in here to not point to a snapshot. For example, here we've got all projects. I'm defining -snapshot. If I go ahead and delete this here, it'll go ahead and not use a snapshot repository. So snapshot's great when you're doing multiple iterations of the same thing. And now we've published a Nexus repository successfully, so you're ready to go.
This concludes the repository manager section. You should now be able to publish your project to a repository manager service, whether it's Nexus, Artifactory, or Bintray. We're at the end of our journey. We hope you found this tutorial helpful on building up an effective Gradle implementation for your build. Thank you very much.